Okay. How do I share it with you? The link. Yeah, I mean, how do I find a link to share to you? Oh, share. I think it's in share. Okay, I have something. Video link. Okay, copy. Okay. All right, I'm just all right, I've put it there. You are seeing click to exit full screen, but I don't need to exit full screen. I want it in full screen, right? Okay. So inside there, like here, right? I click on transition. Yes. Now I can see it clearly. Can you also see it clearly now? I can see it clearly in my OBS. And in fact, the YouTube is also showing here. Okay. Can you hear the audio? Yeah, because yeah. Then maybe we have to stop this. We have to stop the Zoom. Yeah, yeah.
This two-part question. I think Abraham can start with this.
Okay. An AI job. So more like those who are interested in AI policy and what have you. However, you need to understand the place because you are drafting terms of reference, we are hiring contractors. If you do not understand um, what you want and the ecosystem, how can you actually draft these terms of reference to get the right person? But for fair forward the place because you are drafting terms of reference, we are hiring contractors. You just have if you do not understand prepared and ready to learn. But with the interventions we are putting in place, our focus is not on people who think they are. We are not looking for extraordinary people, if I should say. We want people who are willing and ready to learn. People who are some kind of fire in their belly, ready to take advantage of this space because there is a lot. See, there is a lot you can get from this space. For instance, if you look at, say, the space, there are people in the medical field looking for people who are like data scientists. There are people looking for like Data Pop Alliance, they want a data scientist with a social science background. People think this is a place for IT or software engineers. No, maybe because of the technology involved, but data science has nothing to do with IT or developing software. It is about the insights that you give to the business or to government for development planning that matters. All the IT and the software is just to help you reach a certain end, right? So we are looking for people who are just ready to dig in and to learn. And there is training available. And what I can say is that with all new fields, there is always training available. And Delali will also testify. There's also patience for you to grow on the job and even make mistakes. But this phase will also pass. So if you are listening to us, the earlier you get serious with this and enter this space and try to learn this and build a career in this, the better. And to conclude, I would say that the business side that Delali mentioned is very important. So hiding in your room and learning Python and learning how to create models is not enough. You need domain knowledge. So if you are working in healthcare, you need to understand what your organization is doing. If you are working in marketing, you need to understand what your organization is trying to market. If you are working in international development, you need to understand what your organization seeks to achieve. Domain knowledge is also crucial. Thank you.
Wow, thank you very much for that. So as Abraham said, you need the zeal, the fire, right? To be ready for this. So yes, over to you, Delali.
Yeah, so your question was, what is the preparation available
Okay,
for people, right?
yes. What preparations do your organization give to fresh graduates, and what expectations do you have of them when they join your organization?
Yeah. Okay. Um, so in terms of preparation, as I said, for wave two, before we are a startup, we are so there are two aspects, right? We
Mm-hmm.
have a part where we take you once you have a strong quantitative background. We will train you and then give you projects to do. So you know that we have a part for that.
I guess
You can you all you need to know is make sure that you can write code in Python.
Yes.
You know, you are curious. Curiosity is one big part. You are naturally a curious
Can you hear
person
me?
that will want to understand the why behind things.
Can you hear me?
And once you have that part, the entry level
Let me go
program
on WhatsApp
will
if
be
you can
able
hear
to
me.
train you on the job. Like I said, it's not like we are hiring 20 people right now.
Let me know on
We only
WhatsApp
have
if you
very
can
few
hear me.
opportunities for the entry level. Okay. For the entry level, we have a 6-month window
Let me
where
know on
during that
WhatsApp.
6 months
I'm talking in the
we
room,
will
so
have
let me
you
know.
talk with you know, our data
Can you
science
hear me,
experts, our business domain experts to train you during that 6 months. And then hopefully after the 6 months, you
Can
will
you hear
start
me speak?
contributing and adding value. That is for the entry level. But the job that I
Can you
mentioned, the
hear me
Power
speak?
BI one, this is not an entry level. This one we want somebody who knows how to do it to come and do it, right? So there are two paths. There are certain situations where we are patient and we have time for people to learn on the job, but then there are some high demand and you know high visible and quick turnaround projects where we want people who have experience in doing that to just come and stand and do. So narrowing down your question to the training aspect for wave two, if we take you, for example, right now we have a national service person who is working and this person is not a data scientist from the beginning. We just have to work with that person, right? So as national service timing is also coming, we will look out for people again to pick for national service, and that provides actually a good opportunity for us to train you, you know, within a 6-month period, and hopefully after that you'll be able to contribute. Wave two is also looking for opportunities where we can get people and even help train them for specific companies. So if you are a company on this call, or you are a manager of a company, let's say you work for a bank, or a retail company, and you are really looking for people, but you are just afraid that, okay, I don't know how to train them, you can also contact Wave 2 Analytics. One of the things that we are planning to do is that we can help train the people for you based on some arrangement we can come up with, so that we will train the people for you and then they will come work for you, right? So this is more like a, kind of a resource empowerment for people. Since we have experts in that field, you can hire the people as the business. We have an arrangement and train the people. They will be your hires, but we will train them so they can work for you, right? That's something that we can also do. Okay. The other thing I would like to say is what about the expectation, or what is our expectation when these people come? I think it's really more about curiosity and always thinking about the end application of whatever data science product you are building. So, for example, let's say that we want to solve a fraud problem. Okay, if I bring you as a data scientist, you have to think about, when I build this fraud prediction model, how am I going to how am I going to implement that in a real-time scenario, right? So we want people who will not be just trying to build models in their Jupyter notebook, but people who can actually deploy those models in production and get the real financial output from it. What we have seen in interviewing many people in Ghana is that they're thinking about downloading data into Jupyter, into Excel, importing into notebook and building things. But they're not thinking about how can the bank actually put that model into their operating system, so that if a fraud transaction is being made, the model can detect that and signal the banks about, oh, this is a fraud transaction, and have you call the person who is making the transaction, things like that. So we want people who are not only thinking about the data aspect, but they are thinking about the implementation, right? To summarize what I said, there is I would say there are three aspects. One is understanding the business solution and the data available. That is like the left side, and then the middle side is doing all the machine learning work, and then the right side, which is the implementation side, is making sure you can implement those. So when we are hiring people that already have experience, our expectation is that they will be able to think about these three things: business understanding, building the model, and implementation, right? But if you are hiring you as a new person, we will coach you in all of this, right? So I want to make sure I give the differentiation. So if you hire you as a new person, we will teach you all the work throughout. But if you hire you as somebody who is a manager, like the Maverick research type of job that I kind of spoke about, we want you to think about these three things: business, data process and model building, and then result implementation. And I hope this clarifies the question for you.
Yes. Thank you very much for that, Delali. So, if you are listening, I hope you are noting the differences, right? They talked about roles for entry level people and the kind of support they can give you. And if you are a more experienced person looking for the opportunity, you've also talked about their expectation of you, right? And then also for okay, so I think we've spoken about the very key things today, and our time is up. But then we can take a few questions since we have a little break. We have a little networking session time, so we could steal a few minutes from that. So let me see. Okay, so Abraham, you answered this question. Someone asked about what says, are the scholarship opportunities for masters? Yes, and then are the scholarship opportunities for masters in data science field in the US? Abraham, did you get a question?
So I have answered that it is University of Essex in the UK.
University of Essex is
in the UK.
It's in the UK. Okay,
Yes.
great. So let me see. Okay, so that was from Ransford. Ransford, hope you have the answer now. And then the next question is, what if you don't currently have? Okay, okay. I think Delali, you answered that question already about the BI skill. Then, okay. So, I think people were asking about the BI job opportunity, and Delali has already answered that for that you're looking for someone who already knows BI, right? To come and do that. So if you are ready with your skill set, I think we had on our banner that you should send an email to elvis@way2analytics.com for that opportunity. Yes. So that's it. So let me see any more questions. And if you're interested in the Maverick research opportunities, which is for a manager of data science, the manager of data science position, kindly send your resume to ato.micah@maverickresearch.com. ato.micah@maverickresearch.com. Okay, so there's a question for Lily from Lily AJ for Abraham Sam. It says, can I contact Fairforward to learn on the job?
Okay, so Fair Forward as a project, we do not have opportunities now. We have started hiring. We'll be hiring from September. We'll also be hiring, but even in Ghana, maybe one more addition, and other partner countries, one each. So, but we are working with other partners to create opportunities. And Lily can contact me. So Lily, if you are listening, you can go on LinkedIn and just look for Abraham Kukusam, and you can connect with me, contact me, or through the organizers, because we are working with our partners to train people and help them get jobs. And I think Lily can fit in here. We have
Okay.
actually 3 partners training people for jobs, and some of them GIZ partners, but not Fair Forward project. And even Delali, if you are able to get businesses who are willing to pick people you train, we can talk so that we see how we can facilitate that. Because sometimes organizations also want to play it safe. So they don't want to invest beforehand for their training partner to do the training for them. They want the product, so they want a wait and see approach. But if you can get an organization that is committed to meet you halfway, let's talk and let's see if GIZ can support the training. After all, if they will improve people's life, GIZ wants to be involved. Our motto is to work for a world worth living in. So, yeah. There is a GIZ project called Special Initiative for Jobs. They actually support businesses to train young graduates and then absorb them or send them off to other organizations. They have already supported Amalitech and Get Innotize. And I'm sure these organizations they ring a bell in people's mind. GIZ has already, through Special Initiative for Jobs, has supported Amalitech and Get Innotize. And if you are here and you can help in this regard, contact me. I will link you to the team in GIZ working on this. Their core mandate is to create jobs, and they are interested in the emerging technologies, especially data science and AI, because it is a place where they can actually train people and help them get jobs. Thank you.
Okay, thank you very much for that. So if your company also wanting to train people, train your employees, Delali mentioned that, and Abraham also says that if you want to get connected to GIZ to work with them as well, you can get into contact with him on LinkedIn, right? Abraham Kukusam on LinkedIn. Okay, so I think Delali, you have a question here. The person says, can you expatiate on the essence of data visualization and the data science in data science?
Yeah, that's a good question, and I'm glad that question is asked. So, data visualization is simply a way of summarizing a lot of data into a simple form that can easily communicate the insights. Uh, at the end of the day, what you are going to design for the business user is a nice interface where they can go and say, okay, if a customer has attribute A, B, C, and D, here's the risk of that customer. So again, that's part of data visualization. Okay, it is part of visualizing or seeing the end result of your data science project, whether it is even a simple AI project. So those of you who have Facebook account, you see that when you go to Facebook, it always gives you some summary of how many likes that you have, how many clap that you have on your post. That's also data visualization. That's data science at work right there. So basically, data visualization is the last step to communicate your findings in data for the most part. There is also another interesting part of data visualization, which make it important for data science in exploratory analysis. Okay, when you don't actually know what is happening in the data, you are just really exploring the data to actually derive or even guide yourself the questions to ask. Data visualization play a role. So if you can develop Power BI or Tableau dashboard, users can drag and drop different attributes and then just see how they relate to their outcome or whatever attribute they care about. So it actually gives you an idea to even start asking more and more questions. So you use data visualization in your exploratory stage to understand and see patterns in the data, and then you use it again to communicate the result of your findings. Okay, so it's two ways. One, in exploring and asking more questions about your data, and a two, communicate the result. So I always say that you cannot complete a data science project without doing data visualization. Even when we talk about AI bias, we are going to have a talk this afternoon, and I hope everyone will join that session for you to determine bias in your data. Visualization can easily help you do that. You can basically plot your outcome or whatever you are modeling against all the variables that you have, including race, gender, and you can quickly spot in the visualization if there is a bias on that. So in simple words, they say pictures are worth words, or I don't know, I don't remember exactly how we say that, but pictures are worth 1,000 words. So basically, if you can summarize what it is in a picture in the visualization, you can easily communicate what you want in instead of telling thousand stories, one dashboard can actually give that visualization. So hopefully this gives you some expansion on the essence of data visualization. And I think that Ghana, a lot of people say they are doing data science and they are learning how to code in Python, but they are also forgetting how to create visualizations using Power BI and Tableau. So if you are looking to equip yourself with more skills, I also suggest that in addition to your Python, go and learn how to visualize data with another tool like Tableau or Power BI that are made specifically for data visualization. Okay.
Okay, so wow, that has been so amazing. So many opportunities all around us. So I think we have some of them in the banner in case you missed them. Someone was also saying that it will be possible to have a list of all the opportunities. I think we can do that on our end and broadcast it to all the participants via email later today or tomorrow after the conference. So right now we need to wrap up because we have a networking session after this. Thank you so much, Delali. Thank you so much, Abraham Tukusam, for joining us today to talk about the opportunities available for data scientists, upcoming data scientists, and data enthusiasts, and business intelligence people, data managers, and all that. I think this has been very informative. People have learned a lot on how to get in touch with opportunities all around us. So, on this note, thank you very much, and I would hand over to Deborah to continue with the program.
Wow, wow, what an interesting panel discussion we just had. And I guess everyone noted one or two of the job opportunities that were mentioned and will prepare to submit an application. Thank you once more to Asada and the entire panelists for the great discussion. Remember that this conference is made possible by our sponsors and partners, that is Deep Learning Indaba, Google, Superfluid Labs, Academic City University, Wave 2 Analytics, Maverick Research, Tech TV, Kaggle, and Zindi. Next on our agenda, we have a networking session. And as mentioned earlier, though this event is virtual, but we have created a room that would make it interactive as possible. So head right to our virtual booth on the right hand of the screen to meet new people. You may also meet a few of our speakers there to talk to them in person about job opportunities or how to continue with your career. And in the virtual booth, you can view what our exhibitors have and also leave your questions in the Q&A section on the right-hand side of the screen. The companies or products that are present in the virtual booth are Wave 2 Analytics, Academic City University, the Tech TV show, Algorithm and NLP Ghana, that's Natural Language Processing Ghana, and Name It app, which is a food classification mobile app by Bumi Akirimi. So we'll resume the next session at exactly 1 p.m. to have a talk on reimaging chairs with Alpha Zero AI ideas, explained in simple terms. So see you after the break.
The beat is still key.
Mr. Key Producer.
Hello, everyone, and welcome back from our networking session. I hope you all made it a point to at least speak to one or two people during this session. So next on our agenda is a talk by Dr. Orich Paquet on reimagining chess with AlphaZero AI ideas explained in simple terms. So Orich is a South African research scientist at DeepMind who lost his heart somewhere in the bushville and is always looking for ways to find it. His most recent expedition in this quest is with Deep Learning Indaba and his community of hardworking, dedicated friends and peers. He holds a PhD in machine learning from the University of Cambridge, lived life on the edge in two high-tech startups, managed a team in Apple with Noam Koenigstein, developed the core of the Microsoft recommender system. He was on the initial Xbox One team and is still itching to build the next big thing. You're welcome to the stage, Dr. Orich, and it's really a pleasure to have you.
Deborah, thank you very, very much. Thank you so much. I'm really honored to be here and to speak to you.
Yes. Okay. And I hope the pronunciation of Koenig, I'm not really sure. It's a German
That's
word,
my
right?
colleague Noam Koenigstein. He's a good friend, and we had lots of interesting work together. It was fun.
Okay. All right. So the stage is all yours now.
Thank you very much, Deborah. Okay, so everyone, I'm going to spend the next hour to talk to you about the history of AI through the lens of chess. And the title of the talk is Reimagining Chess Through AlphaZero, an AI Journey Through Time. So I'll tell you about the early ideas of artificial intelligence. I'll talk about modern work that we've done at DeepMind in the form of AlphaZero, and I'll tell you a bit about what the future might hold for AI and chess. So first of all, I'll tell you what AlphaZero is and the history of AI and chess. So chess as a game is a very, very old game. This illustration comes from a Spanish book from the year 1293, where you see two old kings or noblemen playing with white and black pieces against each other, very much like the modern game we have today. My first experiences with artificial intelligence was as a young boy when I started playing chess, and I had this little computer. It was called the Garry Kasparov Advanced Chess Trainer. Now, this was a mechanical, sort of semi-mechanical uh, um, toy. You could move pieces, and through a series of lights, the computer would tell you what it needs to reply. And the technology inside this chess machine was very much traditional. There was no deep learning in it, no machine learning. It used minimax trees, which I'll tell you a little bit about later. And there was nothing advanced, even though it was super advanced for its time. My next encounter with artificial intelligence and chess was an event in the late 1990s where Garry Kasparov, who was then the chess world champion at the time, played against a machine that was built by IBM. And the match took place in New York, in America. I think this is 1996 or 1997. And Garry Kasparov, who was world chess champion, lost against IBM's chess machine, Deep Blue. And I was sitting in my room in South Africa wishing that I could have actually been in that hotel in New York to experience such a historic moment where an AI computer first beat a human chess world champion. It was a groundbreaking and pivotal moment in the history of chess. So chess has always been what I call a petri dish for artificial intelligence. If you do science experiments in a small petri dish, you can see how things grow in a small simulated environment. Now, if you play chess, all the pieces on the board are always visible. So so there's absolutely no hidden states. It's a zero-sum perfect information game. So you could try many ideas in AI in chess, and then find ways to make that or to generalize that to the real world. So for instance, when I play chess, I can see exactly where all the pieces are on the board, and I know perfectly what the rules are. If I were to walk down the street, I might have no idea that a car might come around the corner. So the real world has a lot of uncertainty in terms of its state, with many things that are unobserved. In chess, we see the board perfectly. So it's a nice way to also experiment with ideas in artificial intelligence. Now, here's a quick historical overview of the ideas and the ideals that people had in chess and AI. So I want to take you back to the 1770s first. And in the 1770s, a gentleman called Wolfgang von Kepelen built a mechanical machine called the Mechanical Turk that played chess in the European courts, and it was a semi-AI. Like there was a gentleman hidden, a tiny man hidden inside this box, and it moved the pieces. I'll show you what it looked like in the slides after that. I'll tell you a bit about what's happened in the 40s and 50s. In the 1940s, a gentleman called Claude Shannon, who many say is the father of information theory, wrote a seminal paper called Programming a Computer for Playing Chess. And most of the ideas of Claude Shannon from 1949 are still in use in chess engines today. The idea of evaluating the position, minimax search trees, search in general. I mentioned 1997 to you, the year when Garry Kasparov lost against Deep Blue in chess. And when I was doing my undergrad degree, we all looked back at the 1997 moment where the chess champion lost against a machine. And people at the time said Go, which is a Chinese game, is so much more complex than chess in terms of the number of moves that could be made and the width and the depth of the search tree, that it would be a million years before anyone ever builds a computer that could beat the world's top Go players. And actually, it wasn't very long. It was 20 years after that, in 2016, when DeepMind's AlphaGo program beat the strongest Go player in the world, in Seoul, in South Korea. And that was another seminal moment for the development of AI and games. If you'd like to know more, or if you want to learn more, write down that you could watch the AlphaGo movie, and it's for free on YouTube. It tells the entire story of the development of AlphaGo and what the technology is and how the match in Seoul played out. It's definitely worth watched. I've watched it more than once, and actually we watched it at the first second deep learning Indaba 3 or 4 years ago. Everyone together. So let me take you back to the 1770s. So this is a picture of what the mechanical Turk looked like. You'll see that there's a box, and inside the box there's a crazy amount of levers, and there's space for someone to climb into that box and control a puppet through a sequence of levers that could be pulled. And the person inside the box had a view of the chessboard and would manipulate the puppet, the mechanical puppet, to make moves. And no one actually knew that there was a person hidden inside the box. The inventor was a gentleman called Wolfgang von Kempelen, and he wanted to create something nice for Empress Maria Theresa of Austria. And this toured the European courts. And there's another picture in here that shows that a human was actually hidden inside, and through an intricate sequence of mirrors, you would never know that someone was hidden. If you opened one door, you'd look into a mirror, and the person could secretly and quietly slide to another part of the box. This mechanical Turk chess player, which is AI, but it's not really AI because there's really a human in the loop that no one knew about, had some victims. So what do these men have in common? On the left, we have Benjamin Franklin. He's on the $100 American note. And on the right, we have Napoleon. And both of them actually lost to the mechanical Turk. So we want to build AI systems, but we can't always rely on putting a human inside a box to make our decisions for us. We actually want to go beyond that. So in Alan Turing's digital archives, which are also online, I found this paper, and I'll just read a few questions to you from this paper. The paper is called Faster Than Thought, and it was published in 1953. And Alan Turing, in the early 50s, asked the question. He said, when one is asked to make a machine to play chess, there's several possible meanings to the words. Then it's like, then he just said, could a machine play chess according to the rules? Point 1. And then point 2 is, could a machine solve problems? Point 3 was, could a machine play a reasonably good game of chess? And then point 4 and 5 are the really interesting ones. Point 4 on the left hand, on the right hand side, Alan Turing asked on this faded piece of paper, he said, could one make a machine to play chess, and then for that machine to improve its play game by game, profiting from its own experience? And then he added 2 more questions. The number 5 was, could one make a machine which would answer questions when the questions are put to it in such a way that it's impossible to distinguish this machine's answer from that of a human's answer? So number 5 is the famous Turing test, which you might have heard about. But number 4 is an interesting question. He said, can you make a machine that can play chess? And then secondly, can this machine self-improve through playing games over and over again, learn from its own experience, and become better and better? And maybe I could just tell you what Alan Turing thinks. For questions 4 and 5, back in 1953, says, this is like 4 lines from the top, he says, to questions 4 and 5, I say, I believe so, but I know of no really convincing argument to support the belief, and I don't have any argument to disprove it. And the good news now is that, at least for question 4, another 70 years on, the answer is yes, we could do that. And I'll tell you in this talk how it's done. So traditional chess engines contain a lot of handcrafted rules. You could almost see them as if then else rules, although that's an oversimplification. So you would write a function that evaluates a position, and then through something called minimax search with some careful pruning, evaluate many positions over and over again in the search of the best one. The system that I'll tell you about in this talk, AlphaZero, does away with all traditional hand-coded rules. And there's also absolutely no manual feature extraction. So it replaces those with 3 components to learn to play chess. A component that can learn, a component that can search, and a component that can self-improve. So if you have time and you don't know what to put on your Christmas wish list, there's a very interesting book and fascinating book written by Matthew Sadler and Natasha Reagan called Game Changer. And it explains some of the games that AlphaZero produced and some of the technology behind it. Just as a summary, the system that I'll tell you about sits halfway between the number of evaluations that top humans would do and that top engines would do. Well, it's halfway on a logarithmic scale. So top humans would typically look at hundreds of positions, evaluations before they make a move. AlphaZero, tens of thousands, and then top engines, millions to tens or more millions of evaluations of positions. So as an AI researcher, we'd really like to understand how humans think. So it's a nice challenge to try and build systems that get closer to the number of evaluations that top humans do while still maintaining a very high performance. Just as a scientific journey on its own, that's a very interesting exercise. So these are the components of an adaptive self-learning, self-improving system. So I'll go through all of them very slowly and explain how it works. So we've got 4 parts that repeat in a loop. We need a part that learns, almost like a human. We need a part that makes decisions. So imagine you make a decision of what you want to do today. Your decision changes the world, and then of course you see consequences, and that should let you learn a bit more. So this is all very nice in an abstract setting, but how does it look in reality? So let's imagine I want to build a superhuman self-learned neural network AI chess system. So my starting point would be a pile of data. So I've illustrated this with that massive pile of files, paper files, but actually this should be a very long list of chess games. So chess game has many positions and then finally a terminal state. So each position I'll denote with S. It's called a state. So this data has a long list of states and then an outcome, whether someone wins, whether the game is equal, or whether a side is lost. And then there'll be many such games. So every position in a chess game could ultimately lead to an outcome. So in this position over here, white could have either won, lost, or drawn, and the outcome is 1 or a half or 0. The next thing you'll do as a machine learner, after someone has given you this massive treasure trove of data, it could actually be really bad data as well, is to build a neural network that approximates 2 things. The first one is a neural network that approximates the value. So the probability that if you continue playing like you do, that you are going to win the game. So just as a reminder, S is the state and Z here is the outcome. So we care about the expected value of the outcome of the game given the current state. And the neural network just learns a predictor from board to 0, -1, or a half. Or depending on how you want to code it, or -1, 0, and 1, if you rescale it. We'll learn a second neural network, and the second neural network will be called the policy neural network. So if faced with a position like this, I would have to make a move, and the policy network will put a probability on each of the legal moves. So for instance, in my game, I might have observed that from this state or position X, white might have made a move, and that leads to a next state. And there could be many different moves. So we'll learn a second predictor that predicts what move is typically made in this position um, from data. So the state leads to a next, given a next move action, leads to another state deterministically. So the second neural network is a policy network, and this should be able to generalize. So given any state or any board, this network should predict what good candidate moves are to consider for evaluation. And the policy network gives you a probability of what next action to play given the state. So once you've trained these two neural networks, or train them halfway at least, you'll use them to make some decisions. And decision making is done by search, by something called Monte Carlo tree search. So what I've illustrated on the right is the policy network deciding which move to consider to evaluate next. Then the move would be expanded, and I'll explain this whole process in greater detail in a few minutes. So don't worry if you don't follow everything. The policy network would decide which moves to expand next, and they would be expanded and evaluated. And finally, we'll hit a root node, or sorry, a leaf node, like I've shown at the bottom here. And at that point, the position would be evaluated, and its value would be propagated all the way up to the root. And we'll repeat this process over and over and over and over and over again. And at some point, there would be a path that has been visited more than any other path. And then that is the move that is played by AlphaZero. So in reinforcement learning, there is a trade-off between exploration and exploitation in search. So exploration just means that if given infinite time, you actually want to be able to try every move, because what if a policy network doesn't put a lot of weight on a really good move? Exploitation means that if given infinite time, you really want to, through search, visit the best move most frequently. Otherwise, you'll never play it. So I've now learned a neural network. I've used it to make decisions. And now I'll make a move. And so I change the world. So through the decision making and changing the world parts, AlphaZero plays against itself over and over and over again to generate many, many, many more games. And those games, because they use search, are slightly better. So now we have improved data. And because we have improved data with better quality games, we could go back to the learning stage and continue training the neural network. And the neural network would then learn to make better move predictions from better data on the ground. Okay. So I'm now going to go into a few slides of technical detail for people who are really interested in how the technicalities of the system works. So I mentioned that the learning system has two neural networks. So we have two neural networks in AlphaZero. One takes in a position and predicts the probability of the game being won or lost or drawn from that position. And the second neural network is the policy network, and it predicts which moves should be considered next when playing with against an opponent. I'm going to put those in one massive neural network, and this is what it looks like. Don't fear, we'll explain it very, very, very slowly. So I'll take away the two neural networks at the side and then walk you from the bottom to the top. So we'll start at the very bottom. At the very bottom, we'll see the board position or the state as an input. And then there are 20 layers of what's called a residual network or ResNet blocks. And the size of these are 8 by 8 with a certain number of channels, bearing in mind that a chessboard is an 8 by 8 board. So the 8 by 8 board is basically copied and copied over and over through many non-linearities with many channels. And finally, after layer 20, the neural network would split into two parts, a value head and a policy head. So the value head at the left-hand side would just apply some linear layer and then map it down to scalar and then put it through a tanh to make it a number between -1 and 1. On the right-hand side, the policy network would still apply another convolution layer and then flatten it so that we have what's called logits, for in technical terms, a softmax. So it gives you probabilities over all moves. You don't really have to get bogged down with the absolute details of what the network is, but maybe there are a few bits of terminology that you'll encounter in your career as data scientists and AI researchers. The first one is the word torso, like a body has a torso, like your heart and your upper body. So this part in the neural network that's like a single column that just stacks ResNet blocks, that's called the torso of the network. And then you'll see the torso splits into two heads. So there are two parts that's predicted from the 20th layer or 90th layer of computation. So two things to note is that if you ever hear the word torso in a deep neural network or AI lecture, you'll know what this means. If someone speaks about a head in a deep neural network, it just means that after a few layers of computation, the computation splits and it does multiple things. So in this case, there are two heads. Sounds really weird, a torso with two heads, but there are two heads and each predicts a different thing. And that's the way that these two parts of the AI system is implemented. So if you want to learn more, take a pencil and write down the word ResNets or residual networks, because they appear in computer vision and in many other places in deep learning. Why they are special is that they allow back propagation of gradients through the network very efficiently. Just in a second, for anyone who's interested in technical details, whenever you train a very, very deep neural network, there's always the risk that the signal that gets in at the top never propagates and makes its way down all the way to the bottom. So somewhere the gradients get dissolved and they completely disappear, and there's nothing that changes if you want to adapt the weights in the lower parts of your network. The ResNet architecture gets around that because it allows you to backpropagate the weights fairly efficiently all the way down to the input layer. So it's a great tool for very deep neural networks. There are others, of course, but it's a great start. It's a good starting point. So write down ResNets or residual networks. Okay, so now we get to decision making, and I'll explain this whole search part to you. So now that we have a network that predicts the next move and that predicts what the ultimate score of the game would be, how could we use it in search? We'll use it in Monte Carlo tree search. So let's say I give you a position or a state, and I ask of you to make a move on, I think it's white to play now, on behalf of the white sides. How will you do it? For Monte Carlo tree search, in this particular algorithm, you'd first apply your policy network. So it's going to look at the board, and then it's going to give a weight on each of the possible next move, a non-negative weight that sums to 1, a probability. So in this case, you'll see that each of the next states has a probability, and they're indicated with the bar. As soon as I have that probability, I'll use it in an action selection rule. And I'll explain the action selection rule in detail in a few more slides. So don't worry if you don't understand it yet. But the action selection rule says, given these probabilities and a few other things, I'm going to take the action that maximizes something. Like, remember, we always want to do the best thing. Sometimes we want to explore, but we really want to do the best thing, like make the best move. So the action will be the action that maximizes the sum of two terms. And I'll explain the two terms a bit later. But the first part of the term is something called the action value. And it's an estimate that we've estimated of how good a move A in position or state S is. And this is going to be refined by search. So at this point, you might ask me, what on earth is this Q function, Q of state and action? Where does it come from? I'll tell you in a few minutes, but we'll have that. And the second part is an expression that I'll also explain. And this is an expression that allows you to explore other moves. So there's a trade-off between making the best action according to our estimates and exploring. Now, the prior weights will go into the second term, together with all the past visit counts and all other information that we have from the network. Okay, so we'll pick the next action as the action that maximizes an expression. So for every next move or next action, we'll evaluate the expression, and then we'll pick the action that maximizes it. So let's say we'll pick that action. That action A maximizes. So then we'll create a little search tree, and we'll move to the next state. So this is now thinking into the future. So we're rolling into the future. So we'll repeat the same process. So for the position or state that we're thinking about, we would again evaluate it with the prior network, again use an action selection rule to determine which move to select 2 moves ahead, and then 3 moves ahead, until finally we reach a leaf position at a certain or maximum search depth. So let's say this is 20 moves ahead. Once we reach this leaf position, we need to evaluate it to determine whether it's a good position for us or a bad position, or and at that point, we'll apply the second neural network, or the second head, which is the value head. So we'll evaluate this position. So if this is great for me, the answer would be +1, I'm winning. If this is a terrible position for me, the answer would be -1, I'm losing. If the position is completely equal, the answer would be 0. It's just a drawn position. No one's really winning or losing. It's completely equal. After we've done that for the leaf position, we need to take this value that we've computed, and we need to back it up. By backing it up, I mean that this value needs to somehow make its way all the way back to the root in this one path of a search tree. So I'll back it up by keeping track of a few numbers on every branch or connection in this search tree. And the numbers are the following. So I haven't filled them in. I'll have a number for the sum of all the v's that path has already seen. So so if I back up a v, that or I back up an evaluation, that evaluation will be added to every v sum in the path. The second thing I'll track is actually just the number of times that I've encountered that path before. And the third thing I'll track is the state action value estimate. Okay, so you'll see in this notation that n takes in a state and an action. So it actually sits on a blue arrow. The blue arrow is a state that connects you to a certain action. The same for the counts, the same for the sum of all my v's. Okay, so how do I back this up? It's really, really easy. I first take my estimate, like whether I'm winning, like +1, if I'm drawing, it's 0, or whether I'm completely losing, -1. And then I add it to the sum of v's that I've already seen on the last connection the state to the final action, or the leave action, or leave state. I also increment the number of times that I've gone through that that edge in the tree, and then the state action estimate is just the sum of all the wins, losses, or draws, like the expectations, divided by the number of times. So it's just the average. And so I continue and I propagate that average up again in the tree. So the higher level edge, or the higher edge, gets incremented by my estimate. Gets a +1, and the state action value also gets incremented. And voila, bingo. At this point, I am done with one Monte Carlo tree search simulation. So in my simulation, I've gone from the root all the way down to leave. Bam. And then all the way back up again. And so I've computed, determined what positions to evaluate. I've finally evaluated the bottom one, and then I back up the evaluation to the root again. So that's one Monte Carlo tree search simulation. Now, to actually play chess in practice, we can't just go on one Monte Carlo tree search evaluation. We need to simulate many times to see which move is the best to play. So we need to try other things as well. So we'll start again at the beginning. We'll again evaluate the root position with my neural network, with my policy network. And it's again going to give me the probability of the next move to consider for formula. If you're a clever computer scientist, you would cache it because you've already computed this with a neural network, so you just store it in memory somewhere. And we'll do this over and over again. So this time I'll explain to you a little bit more about the action selection rule. Okay, so going up, I told you that the action selection rule, starting from the beginning, the action selection rule has two parts. It considers the action value estimate, Q, which I've just showed you where it sits and how it's computed. But it also considers another term, U, that trades off exploration with exploitation. So I'll now explain the second term to you, going down. Okay, so we're done with one Monte Carlo tree search simulation, and we're doing the next one. So we compute the prior again, and now our action selection formula in greater detail says this. We know how to exploit by taking the action value, the Q that we've computed, like whether a next action is probably winning, losing, or drawing. We like the winning ones because we want to win the chess game. But we also want to try moves that we might not necessarily consider very early on. So the second term has two parts. The first one is just a constant that slowly grows with the number of visits. But the second part is it looks at the probability of the state actions. So I don't know if I can add a pointer. There you can see it. Okay, so these probabilities that I compute up here are copied down here in the formula, the probability of taking the next action in a state. And this means if I just look at this term where the mouse is hovering over, if I just look at that term, it means that this explore term, this U, would say, or would prefer this high probability action to be like explored first, and then maybe a bit later we would want to explore the next highest probability one, and then the next highest probability one, and then the next highest probability one. Okay, it has a last term that looks at the square root of the number of visits for every action, or for every state, and then it's normalized by the number of times any edge, any state actions are being visited. And this ensures that as you keep on exploring, or as you keep on evaluating, like at some point there would be some action that has a tiny probability of ever being a good move according to your neural network, but maybe it's the winning move. This last part would just ensure that eventually you are going to try that move in case it's an absolutely amazing move. So the literature behind this is based on something called multi-armed bandits. So it's so the idea is that you go into a room. In the literature, it's a casino where you try different slots, and one slot machine is an amazing slot machine. So you try and pull every arm of a slot machine until you figure out which one's the amazing one. And you want to also get as much money as you can. So you try and pull the best arm, but you also want to try and explore the others. It's very much the same here. Like you want to try and explore the best move that you can, but you also want to make sure that you've got some time to explore all the other moves that might even be better, even though your prior belief is that they're not. Okay, so this is then the second part of the action selection formula. So we repeat again. We compute the value, this action selection value for every action, and then we just pick the maximum again. But now you should note that because we've done one Monte Carlo research simulation, the numbers will change a bit. So we're going to pick a different branch, and maybe this time we choose a different path to explore and to evaluate. So the next simulation might go down to different leaf node. We'll evaluate that leaf node and then back the value up to the top again. And then after many, many, many Monte Carlo research simulations, there's one path that has more visit counts than any other. And there's one next move that has more visit counts than any other. And that is then, bingo, that's the move we play. That's, according to our simulation, the best move. Great. And we wait for our opponent to play. Okay, so if you want to learn more, write down Monte Carlo research and find out what a multi-armed bandit is. If you want to learn more about this topic. Okay, let's look at it once more, just in 2 or 3 minutes. And I'll do it because someone once told me that if you write a research paper, you need to do the following. They say that to write a good research paper, you first have to tell people what you're going to tell them. Then you have to tell them, and then you have to tell them what you told them. So I'll just quickly tell you what I told them, just so that you've got the big picture again. So an adaptive self-improving system has a lot of data. In this case, it's chess data, and it has a learning part. The learning part in our case is a neural network that just learns how to predict game outcomes from data given a position. It has two parts. It learns the ultimate outcome from a position, given the way we play, and it learns how to predict the next move from a position. So if you have a system that can learn, then it has to make decisions in the real world. Decision making, I've explained to you, it uses the neural network in something called Monte Carlo research to figure out what move to actually play. So it takes the neural network and it refines it to make the moves more accurate. And then once I've traded off exploration and exploitation, there would be one next move that would be simulated or visited more than any other, and that's the one I play, and that then changes the world because the board state looks different. I've made my move, and through self-play, AlphaZero plays many games against itself, and then that leads to a stack of better games, and then this whole process continues. And actually, it starts at being the most ignorant, naive baby neural network, and just by playing itself, it becomes a superhuman strong neural network, probably the best there is at the moment. All right. So what about AI and the real world? Okay, so imagine I was going to give this talk to you on a stage, and in chess, all the feedback is very clear. You win, you lose, you draw. You listening to the talk might be yawning, you might be rolling your eyes, you might be cheering in the background, you might be throwing too much. Like I don't know that. So the feedback signal in the real world is a lot more complex to digest than the clarity that you have in this chess petri dish. So you need to treat many unobserved states. So there are many challenges in taking the work in chess and applying it to problems where the world is a lot more noisy. But it's a good step in the direction of artificial general intelligence. Okay, in the last few minutes, I'll just tell you about a small project that I was involved in. And the background is the following. So the background is that modern chess today looks like this. So this is the World Chess Championship match between Magnus Carlsen and Fabiano Caruana. So they were the two top players in 2018 that played for the World Championship match. And if you look at the 12 games that they played in their match, you'd see that all 12 games, where they think for a very long time, are drawn. And so then they had to play very fast games to determine. It's almost like a penalty shootout to determine who wins the ultimate match and who becomes chess world champion. Now, many more games are drawn because chess, as I've told you, the way we know it today, has been set for hundreds of years. So can we use AlphaZero to figure out if there are any tweaks or variants of chess that will make chess a little bit more unequal, where one side has a greater chance to win, or that will take away this extreme weight of opening preparation for players. So just to give an example, my Christmas present in 1995 and 1996 was a book with chess openings, and this was quite a thick book. It was this thick. This was like before computers were really a big thing, at least in South Africa. And I studied chess openings, just like these grandmasters study. So that's part of any chess player's preparation. So we worked with a former world chess champion, Vladimir Kramnik, and used AlphaZero to explore what games would look like at a superhuman level if the rules of chess were slightly different. And we changed the rules. We changed a number of rules, trained AlphaZero from scratch, and then looked at whether the ultimate games played by the superhuman system is actually interesting or even more drawn than modern chess is today. If you want to read a 100-page paper, you're very welcome to find this on archive, and there will be something in ACM Communication soon. It's called Assessing Game Balance with AlphaZero, exploring alternative rule sets with chess. But I won't bore you with 100 pages. I'll just tell you what the what if is. And the what if is, what if there are some atomic rule changes to chess? So I'll just give one example. So in the left-hand side, if you're a chess player, you'd know that initially a pawn could move 2 squares. What if pawns can't ever move 2 squares? What if they could only move 1 square? Would chess look the same? Or what if a stalemate is equal to a win? So in this case, black's king is not in check, but he can't go anywhere. But that's still a win for a white. And currently this would count as a draw. Would this make chess different, and how different? In the left-hand case, we have actually shown that it makes chess more drawn than it is. There are a few more. So pawns could move 1 square at a time when they're closer to the 8th rank. In this case, we've explored a variant called torpedo chess, and it allows pawns to always move 2 squares at a time. And there are a few others. What we found by simulating these with AlphaZero is that there are some tweaks to the rules of chess that would make chess more decisive, that would give the side that starts playing a greater opportunity to try and capture victory. It would make chess more complicated or dynamic, or it would make it more drawn. So why do we do this? Because modern chess has taken centuries to develop, and it's taken centuries of play by top humans to determine what the best moves are, what the state of the game is, and it's taken decades to develop chess engines that could play chess under the current rules. Because we now have an AI system that could learn itself how to play superhuman chess, it's very easy to tweak the rules and then just let it learn by itself, and then explore and do analysis on what the ultimate outcome of the games are. It turns out that this analysis actually shown that some of the openings that Vladimir Kramnik popularized when he beat Kasparov, when he became world champion, these are actually the openings that AlphaZero prefers. And if you read the paper, you'll see some interesting spikes in some openings. This just shows differences in diversity. I'll let you read the paper. I won't spend too much time on it. The final interesting thing that we learned is that we could actually, from this massive AlphaZero network, distill how important or how much weight AlphaZero typically assigns to every piece on average. Now, if you're a chess player and you learn chess from scratch, your teacher might tell you that a pawn counts for 1 point, a knight for 3 points, a bishop for 3 points, a rook or a castle for 5 points, and a queen for 9. It's like 9 points. So you should never exchange a queen just for a pawn. That's bad. And these piece values have been established over the years through human plans. It's very interesting to see that we could actually distill this from AlphaZero, and then AlphaZero would give very much the same piece values for classical chess than what you learn in primary school as a beginner from your chess coach. So I'll conclude on that. The grand journey of AI and chess and having a human in the loop hiding in the box, and the thoughts of Alan Turing saying, can we ever build a system that could learn from its own experience to play chess? The ideas of Claude Shannon that first explored and stated what a minimax search would look like and how you evaluate a position. The work of IBM building Deep Blue, the work of DeepMind building AlphaGo, Kasparov losing, and so on up to the future. And at this point, I want to thank the IndabaX Ghana organizing team for putting up a fabulous and fantastic and well-organized show. And as an African myself, I'm really excited to see how machine learning is strengthened in Africa. There are IndabaX and similar events happening in many countries across the continent, and the aim is to strengthen machine learning, like in Africa ourselves. And so long may we live to strengthen each other and our discipline in Africa. Thank you very much. Okay, and I think we've got some time. We've got 10 minutes for questions. So Deborah, why don't we see if anyone in the audience has questions, or otherwise I can talk about a few other things.
We will take some questions. Thank you so much for the presentation. We already have some questions from the audience. So the first question says, DeepMind is a leading researcher into AI methods and continues looking ways where computers can perform humans with certain tasks. And AlphaZero is one great example. What do you think further research in reinforcement learning can add to the current level or extend machine learning and AI techniques? Does it promise getting us closer to what we know as artificial general intelligence?
Yeah, I do think so. There is an amazing amount of things that we do not know. We do not adequately know how to interpret these methods. If we think about how AlphaZero trains over time, that could teach us something about how humans learn. The challenges are big, though. In chess, you see all the pieces. Many things in the world are unobserved. So I'm going to take my DeepMind hat off now and put like just the Ulrich or deep learning Indaba hat on. A friend of mine told me 10 years ago that his children would never have to take a driving license themselves, a driving license test when they drive. So at some point, self-driving cars will be a reality, and that's but it's really driven by reinforcement learning. So self-driving cars might not be artificial general intelligence, but it's a crazily difficult problem that I think will be solved at some point soon. This is like not my DeepMind hat. This is like my personal Ulrich hat speaking. In terms of other contributions, next to AlphaZero. You might have seen a press release yesterday about DeepMind's AlphaFold paper in Nature, which almost solves the protein folding problem. And I say almost because I know there are many many unknowns in there, and that code is actually open source on GitHub, I believe. So I invite anyone to dig into that. There are, of course, many things that DeepMind's working on that I can't yet speak about. But what I can say is that someone once told me when I was in primary school that what we understand of the world is the layer of paint on top of the Carlton building in Johannesburg. So the Carlton Center in Johannesburg is this massive 200-something meter tall building. And if you think of that building as the entire stack of knowledge, we know the layer of paint at the top. Like that's a fraction of what this person said we know. And I sort of agrees with that when I think about AI and reinforcement learning and deep learning. So it's not solved at all. Is that a fine answer?
A fine answer. And the person who asked the question, if you still want to follow up, you can just do that by the chat section. Just write the question if you're not okay with the answer.
Okay.
And the second question is from Justice Agbadu. He says, how do you support clients' projects at DeepMind with self-adaptive and self-improving systems?
How do you support clients? So DeepMind has a whole applied wing, and I'm afraid I wish I could answer on their behalf, but I can't. That's something that the communication team in DeepMind's much better at answering than I would be.
Okay, that's understandable.
I'm sorry for the
No, that's fine. Okay, so we have another question. These AI chess algorithms are outperforming humans. Is this not a confirmation that AI will take our jobs and do them even better? Are you concerned that certain professions will be eliminated by the advancement in AI that DeepMind and others are leading? Do you want me to take the question again?
No, and just to answer, I'm not concerned at all. I know people speak about the next industrial revolution. There's been many. I think the only thing that will happen is that there'll be a shift in how people work and how they interact with AI systems as part of their work. That's probably going to be the only shift. If I read recently that someone said 20 or 30 years ago that computers are going to take over our jobs, and computers are going to make us work fewer hours, and the result is that we actually work more hours probably than we did in a long time, and that computers did not take over our jobs. Actually, we use computers as a tool to communicate and to run things like the Ghana data science. So I expect AI tools to do exactly the same. They'll just supplement our work, and they will enable us to do more creative work. And we could sort of see it in this AlphaZero chess chess work. So we now have a tool that we could use to answer questions that we could have never answered before. So as we're speaking, there is a tournament happening, a chess match between Vladimir Kramnik, who's former world champion, and Vishy Anand, who's a former world champion. And it's going to, they play in 4 minutes in Dortmund in Germany. And they're playing one of the chess variants that we've evaluated in this paper. And they would have never thought of even playing this chess variant professionally in a match between 2 former world champions. If it wasn't for an AI tool that gave them a glimpse into what top level play could look like, and that would give them a validation that it's actually like a really interesting and fun variant to try and explore with many possibilities. So I think AI is going to enable more than anything else.
Okay, thank you so much. I think these are the questions we have. Okay, there's another one. Sorry, We have a last question that says, what general advice will you, Dr. Ulrich, give to young Africans who want to get into a profession like yours?
What general advice?
Yes, advice.
Okay. I would read Gorman and Rives' Data Structures and Algorithms book, or read a very good Data Structures and Algorithms core computer science book that tells you everything about the trees. That's one. The second thing I would do is
Could you please come again with the name of the book so that we can
I'll
write
have
it
to I'll
down?
have to Google it. So maybe I could send it to you, and you could send the link to or the book's title to everyone who's listening. And the second thing I would do is I would do a really, really good statistics and probability course. Much of modern machine learning is built on a really solid foundation of statistics and probability theory. And my experience across Africa is that people are incredible coders and extremely inventive and could pull things together and could hack and could build amazing things. And then somehow in education, core probability is omitted. And I think that's if I were to consider like what I would need for a career, I would supplement my Python skills with core probability skills.
Okay, that's really a good one. Thank you so much, Dr. Ulrich Paquet, for the knowledge shared with us. I really learned a lot, and I guess the participants did as well. And we guess would have access to the slides as well.
Yes, I'll send you PDFs for the slides. And Deborah, thank you so much for the invitation. I want to encourage everyone who's attending this and listening to this. The future is extremely bright, and there is a crazy amount of activity happening in Africa at the moment in the AI space. VC investments, startups happening, courses starting, community groups plowing ahead. I almost want to tell you this is the best time to be in AI than you could have ever hoped for. So I hope to see you at the Deep Learning Indaba when we could host one where everyone could gather in person. But until then, I'll say goodbye virtually.
Okay, goodbye to you too, Ulrich, and thank you so much once again.
Thanks, Deborah. Thank you, everyone. Take care.
Okay, bye.
Bye.
Okay, so we move on to our next session, but before then, we'd want to take a quick break. The next session resumes at 2:15 GMT. So for the next 15 minutes, I'll encourage you to go to our virtual expo booth and then see what we have there. You would find someone you can talk there, ask questions about anything that is bothering your mind with regards to their products. So we have with two analytics. We have Academic City University, College, TV show, Algorithm, that's NLP Ghana, Natural Language Processing Ghana, and the Name a Food app. So head right now and ask questions that you may have. See you in a few minutes.
Mr. Key Producer.
Hello and welcome back from the break. And if you are just joining, this is the Ghana Data Science Summit in IndabaX 2021. We are continuing with our educative and interesting talks from all our wonderful speakers. Remember, we'll be announcing winners of our Zindi competition, which was launched a few days before the conference. Stay tuned to hear the awards our winners will be receiving after all our talks today. Next on our agenda, we have a talk on the success of grassroots NLP in Africa, a model to replicate. This talk will be delivered by Jade Abbott. Jade is a machine learning lead at Retro Rabbit in South Africa. She has an MSc Computer Science from the University of Pretoria and works as a software engineer across Africa in every field from fintech to NGOs to startups. Currently, she trains and deploys deep learning systems to perform a variety of tasks for real-world systems. In 2019, she co-founded Masakani, an open research grassroots natural language processing initiative for Africans and by Africans, which aims to spur research into NLP for African languages. Currently boasting over 400 members from 38 African countries and 13 affiliated publications. Wow. You're welcome on stage, Jade.
Thank you so much, Deborah, for the lovely intro.
And it's really great to have you here.
Thank you for inviting me. I'm very excited to be here and talk to you guys.
Yeah. Okay. So the stage is all yours now, Jade. Enjoy.
Thank you. So thanks everyone for joining me today. So today I'm not going to be talking about my day job. Today we'll be talking about my night hustle, which is a thing that's really, really probably the closest thing to my heart at the moment. And I hope everyone can learn something. I think one of the key things I'd like people to take away is how can, just kind of give people the confidence that if you try these types of initiatives, just sort of the success you can get from them. And I want to encourage everyone to get involved either with Masakane or to get involved in other spaces and other initiatives, or even start their own in a kind of machine learning domain that might be missing. My slides. So 30% of all living languages today are African languages. And language is very important. I think a lot of people talk about a narrative which says we should, just all speak the same. But the thing is, as Nanjala Nyabola, who's a Kenyan author, in her book Digital Democracy and Analog Politics, she says language is not just words. It's a constructed self, an orientation towards the world, an attempt to make sense of external phenomena. Language is the hands with which our minds reach into the world and try and make sense of it. So that's part of it, right? Language is more than just a way of communicating. It is part of how we can communicate. It is part of how we view the world. So despite there being 30% African languages, in the top NLP conferences in 2018, only 0.1% of author affiliations were based in Africa. So despite this massive set of languages that are coming out of the continent, very few are very few publications in the natural language space are occurring in those languages. And so we look at this picture, and here we've kind of got what they call the normalized paper count by country at the 2018 NLP conferences. So these are they're a large group of conferences called the ACL, Association of Computational Linguistics. They've got about 5 or 6 conferences that happen around the world. And here is where the authors originate from. And you can see there's a giant blank spot in the middle where we'd hope there would be some publications over the continent of Africa. And so we might ask ourselves why. Why is it that we've got so much coming out of the rest of the world and not much out of the African continent? And I like to refer to this quote by Ngugi wa Thiong'o, who's another Kenyan author. I tend to like Kenyan authors, apparently. I also like Ghanaian authors. The quote is as follows. The effect of a cultural bomb is to annihilate a people's belief in their names, in their languages, in the environment, in their heritage of struggle, in their unity, in their capacities, and ultimately themselves. This is from Ngugi wa Thiong'o's book, Decolonizing the Mind. And in this book, wa Thiong'o talks about his childhood growing up, where he spoke English. If he spoke anything other than English in school, he would be punished. So if he was speaking to his friends in his native language of Kikuyu, he'd be punished. And this sort of behavior or this sort of effect kind of stemming from these colonial influences is something we see across the African continent. And if we connect language to being, something that's so part of us, by controlling language, we can use it, the colonizers used it as a weapon. And this Steve Biko quote, the most potent weapon in the mind of the oppressor is the mind of the oppressed. And so when we think about the lack of NLP research publications, we're actually dealing with a much bigger societal issue that's been stemming on for generations. And it just emerged in this way. So we might attribute it to this kind of lack of societal focus because, society doesn't focus on African languages because of these colonial forces that, made it improper to speak your own language. And this has trickled down throughout the research space. And as we know in machine learning, or as we've learned today, it's really important to have data sets. And if we don't have text that was even written in those languages, absolutely no way we'd have data sets. We also, the research that is published is not published openly. The data sets aren't published openly, so it's really hard to actually build upon research. This impedes kind of research progress and innovation in the field. And this is quite a complex diagram. I kind of want to break it down. It's something we did in our previous paper. And so to understand further understand what was going on, we said, cool, if we want to build an NLP model, if we want to train something to translate from Tree to English, or we want to do a speech recognition, for example, what are the steps and the stages? Where is the problem occurring? Because it seems that it's not just we don't have data, we must make data. It seems it's much bigger. So if we look at this big picture, we've got kind of our content creators who create the content. We've got annotators who then annotate or translate the content. You've got curators. They put together the data sets. They decide what goes in and what doesn't go in. That gets passed over to what we call language technologists, which is NLP practitioners, machine learning people, computational linguists. And they then take that and they would ideally output some sort of model. And then you'd have evaluators that go look at this model. And behind all of these, you've got stakeholders who are going to use the technology, stakeholders who care for the language. And if we look at the African language, if we look at, like, for instance, perhaps English, the English language or the French language, we'd see that, all of this little pipe, it's got everything it needs in order to function. It's got the right keyboards, the right technical, people can actually have access to technology. There's computational resources. There are, we can identify the language is really easy because all the tools have been built. We've got automatic metrics to evaluate how these models look. So we've got all these necessary agents that exist and interactions and external resources. Whereas if we look in an African context, because of the lack of focus, because of the way that governments often have not prioritized these languages and communities aren't prioritizing their languages, whether it be through education or other policies, we see that this entire wheel of creating NLP tools becomes very constrained. So, we don't have necessarily the right keyboards even to write many of the African languages. We don't, content creators might not be creating content because there's no demand for them to create digital content in the language that they're speaking. So they might not create content in Tree. Instead, they'll create content in English or French. and I've got translators there, but think of it as annotators. People aren't translating it because there's no demand for that. People aren't annotating it because there's no demand for that. And what typically happens is that we've got a lot of people sitting not within Africa, sitting perhaps in Europe or in America, and they're trying to solve NLP for these very low resource languages, such as these African languages. And when they curate the data, they take these big data sets, they often don't even know what they're looking at. They're looking at data that might not even be in the language they're speaking in. It might have loads of errors. They have no way of telling the quality because they don't actually speak the languages with which they're working with. And that kind of like trickles down to both the language technologists and the evaluators. If we can't, if we don't understand the language, we might remove diacritics, which are a nuisance to many machine learning practitioners because they're hard to encode, but are very vital in, for instance, Yoruba translations or Yoruba NLP. And then we get to evaluators, and if the evaluators can't even speak the language, how are they meant to evaluate it? So we've got this very constrained system. So this is why we founded Masakane. So Masakane is a grassroots initiative, whose mission is to kind of strengthen and spur NLP research in African languages for Africans and by Africans. Roughly translate to We Build Together in isiZulu. And our goal is for Africans to shape and own these technological advances towards human dignity, well-being, and equity through inclusive community building, open participatory research, and multidisciplinarity. So when we're saying that we've got a societal issue, it's not just about having a lack of data, we've got a societal issue. We need to come together as a society in order to solve all these many problems. And we've had a great 2 years. It's been 2 years since we founded, and it's got over 400 participants, over 35 African countries, around 40 African languages. We've got over 40 publications. So if I will have a deep dive into them later. I was really excited. I've made a little tool that's really fun to use. We've got around 40 GitHub contributors, and these are quite old stats. I need to go check them out. And kind of our highlights is that in our first year, we got the UNESCO Innovation Award for 2020. And this year, which was completely crazy, is we got the Wikimedia Research Publication of the Year, which was super fun. And at the African NLP workshop, we got the Outstanding Paper Award for one of our papers. So I kind of want to take everyone back and have a look at what's happened in kind of this African NLP space in the past 2 years, all the work that not only has been done by Masakana, but people who aren't even part of the community or are still becoming part of the community. And so instead of doing a boring tree diagram, I've done this, which I thought was fun, because it's a tree and it's an acacia tree, which is a Southern African. I know they've got them in Kenya too. I wonder if they've got them in West Africa. Someone can confirm. In terms of like the space, and I like to visualize these sort of things in different ways. So this is what we're doing today. So kind of the main sort of things that we've seen research in are around data. And in the data space, there's been a lot of data creation for many of the tasks. But we've also expanding on techniques of augmenting our data. If we only have very little data, what are clever ways of augmenting it automatically so we can make the models trained on it more robust? There's a couple of things around digitization. So doing OCR on an African language, so optical character recognition, taking from a piece of printed paper and scanning that back into a digital copy. The OCR doesn't necessarily work for African languages, so there's been really interesting work done there. We've also gone and looked at the world's multilingual data sets that claim to have thousands of languages, and we went and audited the data that they had for many languages and saw the data that they had was riddled with flaws. Sometimes it wasn't even text, it was just weird symbols. We've done a fair amount of work there. And that's kind of what's happening in the data space, and as well as kind of this proper ways of collection and curation, because I think the rest of the world just scrapes blindly when they're trying to get access to data. So they'll just scrape the entire internet and that will be the data set. We find that that's quite unethical. We're also not sure, like the legality, it's got so much wrong with it. So we want to ensure that any data we have, we're collecting in a way that respects, the communities who speak the language, such that they give it consensually and give it willingly, because they know that it'll benefit them. And so this is the kind of the data space, and there's a lot going on there. If we're looking into machine translation, we've done a lot of work and seen a lot of work of evaluating how machine translation techniques do or don't work. We like to do human evaluation because a lot of the automatic metrics don't actually count, as well as data set building. We've done kind of wide scale training of models, discovering where they don't work. There's seen very impressive improvements in the models by just coming up with clever ways of tokenizing the data. So when you're tokenizing, you're taking a sentence and you're splitting it up into either words or subwords, and just doing that well or differently in a way that more effectively captures the language in question can have massive improvements. And we've got a couple of papers on that. Then we've got named entity recognition. So when I talk about named entity recognition, I'm talking about, having, we've got this issue right now is that if I type in a South African name or a Ghanaian name, it's going to tell me that that name is an error. And we need, technology to start understanding that this is our names, this is our places, this is our people, this is our things, this is what we care about. And so named entity recognition, in addition to being like a core NLP task that feeds into many technical like chatbots or other search activities, it also is kind of a core aspect of ensuring that technology understands and knows who we are. And there we've seen large successes. One of our biggest initiatives run by David Adelani is kind of doing transfer learning across African languages so that we can improve the models that for this, as well as kind of community data set development we've done. And then I've got this other section in the middle, which I'm calling them African tasks. And they're African tasks because often you don't see them in other parts of the world, either because it's a task that's already been solved, but more often it's a task that wasn't necessarily seen. So diacritic restoration, as I've mentioned, for a language such as Yoruba is really important. And because the keyboards and the technology did not support the languages properly, it did not support people typing with diacritics. It did not aid them. So the ability to take text and restore the diacritics so that they're easier to read and write and speak is a really important one, particularly in the African context. Then a big focus is around ethics. How do we build tools that are ethical, that are unbiased, that do not reflect the injustices of the past? A lot of the things that need to be reckoned with in the NLP space in Africa are that much of the data that exists is religious, so in various religions, which means not only does it necessarily work on another domain, it probably doesn't, but it also might carry certain Western ideas captured by missionaries at some stage. It also might capture, if everything we're reading is written by the West, then it's not really dealing with our own news and our own dialogue. Not only will it not work, but it might also behave in an unbiased manner. And you see this a lot with computer vision, where it trains on, it's been trained in Canada on people who are predominantly white, and then you import that same computer vision tool or facial recognition tool to Africa, and it doesn't work. We're seeing similar things with African, not even African languages, but just even working in the African space. So there's a fair amount on decolonization and bringing in Ubuntu ethics as part of the work. And then with that, script creation. So a lot of the work, many African languages, because they weren't they're documented appropriately, they're actually harder to read and write. So languages that didn't have diacritics should have had diacritics, and that's Europe is a good example of where they added that on later on. There's often many ways one can say a word, but because of the way it was written, that doesn't get captured by it. So even thinking about how we can create new scripts to better capture the words and the sounds that aren't necessarily captured in the kind of Latin alphabet is a really interesting work. And yeah, our keyboards, spell checkers, these are fundamental, and they exist for English, French, and so many other languages. And we're finally seeing work in African languages for that. Next group is sort of the language model space. Here we're talking about data sets. Once again, we're also talking about the architectures, because the architectures used by the West don't necessarily work on our data. They don't necessarily work on our languages. Our languages are extremely complex, or many of them are. And as a result, what worked in the West didn't work here, so we need to change those up. And this kind of goes on in a lesser extent. We've got some work on summarization, some on sentiment, some on classification, some on generating text, generating African text for chatbots and other means, as well as a fair amount on speech. And right now, speech is not something that's, it's something that's coming into focus because it's really necessary. And it's necessary because many languages in Africa are more spoken than they are written. So, for example, Hausa is one of the most spoken languages, but it's not one of the most written languages. People tend not to write in Hausa, but they speak it very widely. So a really fantastic way to kind of support African languages would be to support speech tools. And kind of traditionally, the NLP community and the speech community were kind of separate. We don't believe in that. We believe they're the same community and can really, really help each other. So I made this really fun thing, which I'm going to go to. Hopefully it doesn't destroy my screen. And it's a map that captures not all of the research activity in African NLP, but kind of some from the past 2 years. And we've been developing it in the past week, so this will be updating. But also if you have any research that you come across that wasn't here, like this is a community map, so anyone can add a post here. So this is a little crowdsourced map. And the goal is to show like a different angle on the research that's available. So, for instance, West Africa is actually very, very active. Over here, we can see we've got each of the papers, and you can view them. So I hope to share this with everyone so they can see it. So here, I can go deep dive. I can see the name of the paper. I can see the authors. So this was by the Ghana NLP group, who you've definitely spoken to today. Got the presentation and a link to the paper. And so let's say you're interested in what should we do? Let's do machine translation. We can just quickly look it up. Hopefully that might have sorted already. Don't know if it did, maybe it did. And we can see that it's filtered out many of the ones that are talking about machine translations. Some of them are talking about it in the abstract. So this can be quite a fun tool if you want to break in and you're not sure where to start reading. I hope that you'll enjoy exploring this map. I open it up and sometimes just go explore it and see what's happening. Can see exactly where some of it came from. A lot of there's one trick. I need to get back to the main view. Is that it looks like there's a lot of stuff happening in Chad. Oh wait, this is still filtered. Let me unfilter it. Cool. So you can see the full list. A lot of stuff's happening in Chad. No, that's just what it's. If I put it in Africa and made the location Africa, that's where we put it. So you can see a lot of these are Pan-African papers that are kind of centered over there. I haven't got a really good way of doing that yet. But yeah, I'm hoping this can give you a nice view of what's happening. And we're going to, like I said, community source this so we can keep it up to date. And when we discover stuff, we're going to add things there. So I'm going to go through a couple of sort of the key, if you're looking to move into the space and you're looking to move into kind of the way we do community research, Here are a couple of key papers that kind of outline not only how to do kind of community-based, open, independent research, but also the value of doing it. Why is it important that we do participatory NLP? Why is it important that we have people who can speak the languages actually build the models? So the first one, and this is the one that won the award from Wikimedia, is our paper that we published in EMNLP Findings. Kind of the lesson here, as we're talking that low resourceness is more than just data, it's societal. And this is where we outline a lot of what's happening in as part of the community, a lot of the stuff I've just been through. And the value here is that there've been 47 translation models for 35 African languages. I actually need to go update that because I know there are more. And many of those languages had never been seen before. There was never a machine translation model. Now we can debate whether they're good or not. In fact, many of them aren't because they're trained on very little data. But these are the first publications that are reckoning with these languages. With that, we also did some human evaluation, and we showed the value of doing human evaluation. You get these numbers that seem high, but it's called the blue score. That's the one that's used in machine translation. And if we look at that number, it's essentially meaningless when you look at it alone. So it's really helpful to have humans go and evaluate each of the sentences. So our community went and evaluated these on some data that we had. It was actually quite an interesting story. So we trained on what a Jehovah's Witness data set called the JW300, which is very widely available. It's one of the most multilingual data sets you can get. And then we tried to translate COVID-19 surveys, and we knew this wouldn't work. A lot of people wanted us to translate. We knew it wouldn't work because we knew this is kind of one of the severe limitations of machine translation, is that first, it doesn't deal with new words, and second, if it's been trained on a different domain, it's not going to work. So we tried to translate it, and then we spent a lot of time trying to understand the types of errors it would make. So for example, it would, that's when I check the time, it would biblify words. So instead of saying Canada, it would say Canaan. It did that quite a lot, which was interesting, but not correct. So that's a really cool paper. You'll see we've got 50 or so authors on that paper because this is really what it's about. It's like the entire community coming together to produce these. Each person who's an author there either contributed a model, contributed an evaluation, helped write or edit or position the paper. And so, or actually wrote some code, that's another one, or contributed data, that's the last one. So each person who's an author there has brought value to the project, so they were acknowledged as authors. And kind of what happened in the past couple of months is we said, cool, we've got all these models available, but they're really sort of hard to interact with. So this is very recent, so the past couple of months, we had a team working on a grant from Mozilla Foundation. Actually need to make a correction. They had another team. The speech team was supported by UNESCO, not GIZ. And you can go to those links, and we've deployed some of our models, and we can do slowly deploying more. And the goal here is to kind of understand the failures of these models that we've trained in the JW300 space, in this Jehovah's Witness religious domain. So we got a bunch of translation models in our Masakane web platform. We also have speech models. So here we're doing text to speech. And right now we only have Wolof. That's because the team who started working on it was working in Wolof. So we're looking to how we can expand that to more languages. The next paper, and this one's just been published at Tackle, which is a journal. It's about to be published. And here we built named entity recognition data sets for 10 African languages. These were annotated by our community, and then we trained language models together and did kind of this transfer learning. So transfer learning, the idea here is that, if we can learn something in one language, maybe some of those learnings will be useful in another language. So let's train them together and see how well it works. It was actually really interesting. typically people will transfer from a very high resource language such as English to African languages. And we found our best models came from transferring from Swahili, which has a medium-sized amount of data. So transferring from Swahili into many of the other African languages that we trained on them, including the West African languages, which are actually very different from Swahili, or many of them are. So that's really fun. Once again, you can see the giant list of authors of everyone who participated and did such a great job. And then the last one, which I think I'm going to talk about for the moment, is the data audit, which I mentioned. And we went and looked at these large published data sets from large research institutes such as Facebook and Google, and really went and said, cool, you say you've got language in tree, let's go look at it and see if it's valid, and see what it looks like. And we discovered that at least 15 of the corpora were completely erroneous. They weren't the right language, they were just nonsense. Many of them had less than 50% of sentences, so many languages had less than 50% of sentences that were actually acceptable. And many of them were just completely mislabeled, so they weren't even of the language that they said they were. In addition to that, they went and looked at a couple more features. They looked at whether it was hate speech, whether it was pornography, did like deep dives into a couple of those, and then came up with they've got a whole bunch of statistics in the paper, which is really, really cool. And what was really interesting here is that it was such a big collaboration. It was Masakane, but also one of our sister organizations who do, they're also kind of an open community working with the Turkish languages, the Turkish Interlingua. But also Google and Facebook and Hugging Face, these large organizations who do this sort of research got involved, and that was really cool. So a couple of sort of ongoing initiatives. I'll talk a little bit about each of them. I haven't done like a very great visualization here. I went through my talk a lot quicker than I thought I would. So we might have a bit of time. I mention these because they're a great place if you want to get involved in NLP. Come join us, come be part of the community. I know we've got like a really active group in Ghana who are fantastic, and we work with many of the people there. So it'd be great to see you. So some of the ones that are going on is an extension of the Masakaner, the NER work, where we're expanding, I think, to 30 languages. We're doing a Masakana machine translation one on decolonizing science, where we're taking science papers published by African authors and translating them into 6 African languages. We've got a Makerere, so this is East Africa is doing a very large project where they're doing translation data sets, they're doing classification data sets, they're doing speech, just focusing on kind of just more Swahili, but more than that, so other regional languages, which is really exciting. We've currently got a question answering group that's going on. So they're trying to come up with data sets where you've got a question and you've got answers, and this is a really complicated process. It's actually really interesting, the process they're going through. Got about, I think, 20 people working on that. Very fun. As well as natural language generation. And this is kind of in like a chat box context. There are also about 20 people working on it. Very cool stuff. And we have 2 study NLP groups. So if you're looking to get more involved in natural language processing and you don't know where to start, we have 2 groups. We've got a beginners group, and they're kind of going through machine learning at a much slower pace. It's being run amazingly. Shout out, I think, Brad and Espa, and all of them are running it, and they're doing such a great job. And then we've got another group that are kind of a little bit more advanced. They're looking at neural networks and NLP at the moment. And they've just started a new setup. I think they started last week. So if you're looking to dive in there, this is a great time. I think they meet on Mondays. If you join our Slack group and join the channels, you'll find them. Then we've got a new initiative, which is working on collaborative training. So this idea that we have very few resources. So let's pool the resources we have together and train one model. So if I've got a machine and you've got a machine and you've got a Google Colab and you've got a Google Colab, like, can we pool those resources together to train a single model instead of trying to train one big machine learning model in a space? And one of the last ones is we're working, Niger NLP, they're working on building, looking at kind of hate speech and online safety and sentiment lexicon for a number of Nigerian languages, which is very cool. And so how? I mentioned I want people to replicate this. I want people to see more initiatives, whether they be kind of localized initiatives such as Ghana NLP, or whether they dealing with a particular problem in a particular region, or whether they're kind of pan-African movements in a different space, such as maybe computer vision. How did we get around doing this? And what was really interesting is we did a talk at it was World WMT, which is I think it was the World Machine Translation Conference. It's the big machine translation one. And people immediately, it's so funny, there were a number of European people who were running the conference who said, how do you get people to do anything without money? And I think we all just shook our heads and put our hands in our head and kind of reflected on what it was that was the real reason we were all working on these problems. And my collaborator, Wilhelmina Nakota, said, "This is, our currency is the spirit of Ubuntu. Our currency is, the community and how we build this together. It's the relationships we build. That is why we do this, because we're part of something and we're working on a problem that's really important, but kind of in a more concrete way. So if you were to go do this, there are a number of questions that might pop up. So the first one is, how do you find people? Where do you find people? So for instance, if we're looking kind of, I'd say locally, initiatives such as the IndabaX, such as the Deep Learning Indaba, local meetups, universities. This is where you go speak to them, you send them emails and reach out and do presentations with them and get people on board for the cause you care about. Remotely, Twitter, very effective, conferences, press coverage, publications. There we get a lot of interest. We find a lot of diaspora, people who are living in the United States, people who are, have moved to the UK, who want to reconnect with the countries that they were born in, and they want to reconnect through language and help work on that. And one of the goals is we want to ensure that there's no academic prerequisites. You don't have to be a machine learning person. In fact, we quite welcome people who aren't in machine learning because they can help us with so many other things. They can, they might be really good writers. They can help us understand the failures. We've got translators who work with us. They help us understand, how these tools work, how their translation tools work, what, sort of assistance they need, what sort of things we should be developing for them. So really making this as wide as possible so that anyone can participate. The philosophy within Masakane is that everyone can bring value. In terms of how to assign roles, so you saw we had these roles in our picture. We don't have, those roles move, right? There's no fixed role. You join, you might have something that you specialize in, you've got something that you're interested in, and what we really focus on is kind of knowledge transfer and sharing. So you've got quite what I call peer mentorship, this idea that everyone knows something that another person doesn't know, and so I might be mentoring you on some sort of NLP technique, and you'll be mentoring me on understanding a particular language or understanding how to write a paper or another skill. And we do this in quite a wide collaborative space via Slack, via our weekly meetings. and we live in this, was really interesting as COVID-19 happened, and we were all confined to our homes, and almost nothing changed in Masakane because we'd been distributed already. We'd already been working this way. In fact, we might have spent more time because we had less to do because no one could leave the house. So we spent, I think that's where we did a lot of research that year or last year. I think we're still doing a lot of research. So how do we connect? And we need to set up these kind of digital spaces. So we've got quite an active Slack. I know other communities opted to using Discord. The goal is you want to make it the thing that is most comfortable for everyone to use. So we have Slack and a Google group because some people prefer interacting more in email sense. We have a weekly Zoom meeting, which you should come to. It is at it'll be 5 p.m. Ghana time or UTC time. So please do join. You can find it online. We've got a little virtual reading group, which I think has gone quite quiet at the moment, but we're spurring that up, as well as these multiple study channels, which is very recent, very exciting. And what we try to do is make everything as accessible and as open as possible. This means our meeting notes are public, our results are public, our code is public, our data is on GitHub or on Zenodo, and we try to keep it as open as possible so that not only can the community benefit, but anyone who's not part of the community can also use that to train models, to build businesses, to build up their own startups, perhaps. And anyone can make calls for collaboration. So instead of having like an agenda, we're very, I call it a do-ocracy. If you want to do something, start a Slack group. And that's how you get going, which is rather fun. So you start a Slack group, invite people on the calls, maybe write a post, and then there's a project. And then, my collaborator, Kathleen Simunyu, as she says, is everything starts with a weekly call. It could be a 20-minute call, but you just start with a weekly call. I hope I'm connected. Okay, am I back? Cool. I was worried that I disappeared for a moment, but it seems to be back at the moment. Okay, stable. Okay, thank you, Deborah. So one of the things our goal is to, my slides are off. There's sharing. I think they're going on and off. They're not full screen. I can maybe do it full screen. That better. Thank you. Okay. I hope it wasn't like that for too long. If not, I'll share the slides afterwards so everyone can see them. And so how do we lower these barriers to participation to ensure that everyone can get kind of hands-on experience? So the way we started is we had one project, and it was a good initiator project. So if you're looking to start a movement, have something you can get lots of people to work on. So we try to use a lot of freely available resources. So here it was, we had a project where anyone could train a machine translation model for their African language, providing we had some data. And so we try to use a very wide data set where it had a lot of data, even if that data wasn't necessarily good, even if it wasn't a lot, it was something to start with. We used a package called Joey NMT, which is a machine translation package, which has been built for understanding and accessibility. So it was very easy to use. And then we hacked together this little Jupyter notebook, which you could then use to kind of train this model in your language. And then from there, we started fleshing out tutorials, so videos on how to do this. We started fleshing out guidelines on how to start and what you should try. So having a task where you can get people to, anyone can start is really helpful. And so I showed that picture early on around all these issues that happen in machine translation. And here I can kind of outline how we've started solving that. So all those things that might have been evident in 2018, I think we've tackled, or at least moved the needle on many of them. So in terms of the societal lack of focus, we focused on community building. We focused on language activism and publication. We focused on building Pan-African collaborations as well as mentorship. In terms of the lack of discoverable resources, we wanted to make much of our stuff very public. We worked on the AI4D Zindi dataset competition, which many of you may have participated in, which encourage people to submit data sets and then also later on build models. We had, I think it was a mini grant for AI4D, which I think was in partnership with the Deep Learning Indaba, where then people were then given funds to expand their data gathering efforts. We have an African NLP Zenodo collection. So Zenodo is a place where you can publish data sets and models. We have a collection there, which you can go find and look at. And we have a whole bunch of open data set collection efforts on the go. Like I said, we work on open source code, open data, and open publication. So something like our African NLP workshops, which have been put together for the past 2 years. First one was hosted with iClear, which is one of it was meant to be in Ethiopia. It's one of the top machine learning conferences in the world. And the next one was hosted at EACL, which was this year. And that was super, super fun. And that was it's one of the big NLP conferences. And so that's what we did in that space. Next, we like these workshops published a bunch of papers. So just having that workshop, we collected everyone together. We incentivized people to start working on this. And over the 2 years, I think we've ended up with over 100 papers because of it. It's clear that this novel research is finally happening. Affirmed by the Paper of the Year award. And now we're kind of looking at, the innovation and progress is no longer impeded because we've got all these prerequisites. So what we're seeing emerge is, for instance, Masakane Translate and Speech for Web. We've got a number of participants who've worked on keyboards and spell checkers. So Bonaventure and Chris have done keyboards for fun and Think for Igbo. Bala AI has also built spell checkers and keyboards for South African languages. And then some of our NER models are available on Hugging Face for anyone to use. And these are tools which other people can then take and build upon and use and innovate with. So just to mention, to shout out to 2 initiatives. So number one, Ghana NLP, who've done amazing work in the NLP space. In Ghana, many of the members are large ambassadors of Masakane, and we wouldn't be there without them. And another initiative which I want to draw people's attention to is another group trying to replicate the exact Masakane model, but in the health AI space. So if you're interested in machine learning and health, go join Sasonke Biotic. Can follow them on Twitter at sbiotic or Sasonke Biotic at Africa. I will share those in chat in case anyone's interested. They're doing a very similar initiative. Their meeting is an hour before the Masakane meeting, which should be fun. And so that's all I have to say. I know that was a lot. I will share the slides, and I hope you feel excited about all the natural language processing work that's happening on the continent. And what's really cool here is we're doing it in a way that the rest of the world is only learning about now. And we're doing it in a way that I think is centrally African, which is working together to do this, as opposed to sitting in our labs and doing them in these disjoint ways, just working on our problem. So I hope people enjoyed that. I hope my connection was all right and didn't break up too much. And And I hope everyone has had an excellent conference and continues to have a great conference.
Yes, we did, because we built together. That was a great talk. I really enjoyed it. So we have some questions for you from our participants. The first question is that tokenization is very essential in text classification in NLP. What is tokenization equivalent we can use in speech recognition?
Oh, I have no idea. I'm by no means good at speech. What I would recommend is there are a couple of individuals working in the speech space in Africa. So I would look at, actually, if you go to the little map I have and you look up speech, you'll find a little bit of work. So there's some done by Kathleen Simunyu, and she's been working with Luya, and she has the equivalents there. And then another person to reach out to is Harman Kampas. He's also on the Deep Learning Indaba Committee. And he is kind of one of the big people working in low resource speech on the continent. So I don't know is the answer. I'm not good at speech, but I hope those references are helpful.
Yes, I'm sure the references will be helpful for the person who asked the question. So the second question is that one of the problems of NLP research in African languages is a resource or fund constraints. So can you comment on the source of funds that can support research in NLP for African languages?
Yes. So we've been fortunate enough to collaborate with AI4D. So they funded a lot of the grants that we got. They gave us grants for a lot of the data sets that were worked on. There are a couple of additional grants also facilitated by AI4D. I think they were funded from UNESCO originally. Mozilla Foundation is quite focused on, particularly in speech, but also in other NLP, on building tools. So the Masakane Web was funded by them. So it's a couple of foundations that are quite focused, and approaching them is really helpful. Approaching them as a group is even more helpful. So as an individual researcher, it's quite often hard to navigate. But if you're part of a community, either a localized one or one such as Masakane, we can approach as a group. And we did that. So there was a great call called the Lacuna Fund, which I advise everyone goes and looks at the Lacuna Fund for their funding, because they've got a couple of grants. They're going to do another NLP grant for data sets. And so we've got 4 projects on the go. So 4 of the projects I mentioned are funded by the Lacuna Fund. So there's a lot of development funding around if you know where to access it. We're exploring places getting from the EU. We're exploring other digital, you can sometimes get digital humanities grants from certain universities, but it's quite dependent. I'd say the most helpful funding came from development funds. And if you're part of a community, you often find out about those things. So.
Okay, thank you so much. So the third question is that what do you envision would be some of the most important applications of NLP, especially for African languages in African countries in the next few years?
So the one I think that motivated me to get involved, there's so many, but if I had to pick the first one that came to mind, and the one that motivated me was in education. And I think a lot of African languages seem to be dying out because they're not brought in at a younger age. And there's been numerous studies in the education space about the importance of speaking your own, your home language and learning in your home language as a child, going through high school or going through primary school. And there's a great study by Maki Yankees, who's based at UWC. And she works in that intersection of education and tech. And she went and did a number of studies where they specifically looked at if they provide tools or resources in the languages that the children had around them all the time. So, and particularly in the maths and like science space, they had a significant improvement. They performed a lot better. So I think there's a amazing amount in kind of education. I think that's a huge point of impact, which we'll see in coming years. And then the next one would be kind of general access to information and technological support. So right now it's really hard for us to communicate in the language we prefer on our devices. And I think there's a great scope to start bringing that information to people who might not speak English or French or a dominant language, saying, here's the internet, it's in the language you can speak. So these are kind of two spaces that could be interesting from an application perspective. From a technical perspective, speech. It's going to be speech, I'd say. All the speech work's going to be really interesting. It's going to become a big focus.
Okay, so we can take our last question because we have 4 minutes to go. So the fourth and last question, actually. So in a continent where our educational institutions do not emphasize training students in their own languages, what would you say is the role of these NLP advances for economic development in Africa?
So I think what's happening is people are getting excluded because they don't speak the primary languages as well. I think there's an aspect of that. So people might get economically excluded. There's a great story by an amazing linguist and author and collaborator, Kola Tobison. He tells a story about how he was standing at an ATM and he was behind a guy, and this guy was just trying to withdraw money, but couldn't because the language that was used, not only was it in English, it was also in quite it was using jargon and terms that weren't necessarily something that someone might have grown up with if they hadn't been through a formal education. And he was just resonating how businesses even are losing out on customers, how people cannot participate because the language of engagement isn't that. So I think there's, you might be able to bring education to people. You might be able to bring tools to participate in society if we support the languages on those platforms, on those digital platforms. And then I think there's an interesting discussion that the groups that are working out of the UN in language are talking about is facilitating trade between African countries. And so building tools around support for African languages that kind of are on the boundaries of different countries so that engagement can start happening between those countries using these tools and kind of facilitating trade. So those are two aspects there, which I think are quite interesting in that space.
All right. Thank you so much, Jade, for sharing your experience with us and answering all our questions. We're really, really grateful. And it's a pleasure having you, actually.
Thank you so much for having me, Deborah. And thank you to the entire IndabaX crew. You've done an amazing job.
Thank you too. All right, so I think next we'll be having a short break before our next session that starts at 3:30. So again, kindly move to our virtual expo booth so that you can speak with the people who have set up their booth stands there. So just a reminder, we have Wave 2 Analytics, Academic City University College, the Tech TV Show, Algorithm and NLP Ghana, Natural Language Processing Ghana, Name It Food Classification App, Maverick Research, Xtelix, and Podgauge AI. So kindly move to the virtual booth and interact with them. See you after the break, sorry.
starting key producer.
Hello, welcome back from the break. Remember, this event is proudly made possible by our sponsors and partners: Deep Learning Indaba, Google, Superfluid Labs, Academic City University, Wave 2 Analytics, Maverick Research, Tech TV, Kaggle, and Zindi. Now on our agenda, we have Nyalen Morusi to speak on AI bias and ethics. What is it? What challenges does it bring? And how can it be reduced? So a bit about her. Nyalen is a software engineer and a researcher at Google AI. She is one of the founders of Deep Learning Indaba and is still part of the organizing committee. Before this, she was a senior researcher at the Council for Scientific and Industrial Research. She originates from Lesotho. Help me welcome Nyale Morisi. Hi, Nyale, you're welcome.
Thank you so much, Deborah. Just one little thing about my bio. I did leave the organizing committee of the Indaba in May.
Okay.
So I have handed over to the rest of the committee, which of course are amazing. But thank you so
Okay.
much.
Thank you
As I
too.
told them at that time, I'll always be part of the Indaba family, and I'm having so much joy participating in the Indaba Access. So thank you for this invitation.
You're great. We're happy to have you here as well. So the stage is all yours now.
Thank you. All right. Let's see. Hi, everyone. Usually when I give this talk, it's more of a communication, a back and forth. So let's see how we do. So I'm going to talk to you today about bias in machine learning, what it is, and interestingly, it is an evolving definition. But basically, what it is, why it comes about, what so many researchers are trying to do, and so many institutions, and sometimes even government entities are trying to do in order to ameliorate this. And then I'm just kind of hoping that through this conversation, it will be clear what the role is of the community in, for example, the IndabaX. I personally believe that entities such as these are very instrumental to dealing with bias in machine learning. So overall, bias is, I guess the simplest form is to say, there's a tilt or a preference of one over the other, or a disadvantage of one over the other. And the one over the other could be a person or a group or an entity. So that's basically what we're going to talk about. And so this bias in machine learning is when you have an imbalance of preference between entities. And for our specific case, a lot of the time we talk about an imbalance of preferences between groups of people or individual people. So I like to go back to this drawing, which gives a fundamental understanding of the process of machine learning, which of course this is a stick diagram, and any stick diagram absolutely abstract so many important things here. But a stick diagram also helps with that abstraction for us to talk about the different parts of a system. So machine learning systems, basically, we have got these separate parts. We come up with an idea or a problem that we would like to solve. And Let's see. Am I back now? I have to apologize. I was connected to the wrong network. I was quite surprised by this. So I will start from the slide again. Sorry. I think I was at the almost at the end of this, but what I was talking about was this whole process of machine learning, about how we move from an idea to a post-launch and the tweaking and all of the other. And of course, because this is an ongoing process a lot of the time, you have to go back a couple of steps in order to redo certain thing that, you find some results that were unexpected. Now, why is it important to think through all of these steps? When we're thinking about bias, because as you remember, I said bias is about giving preference over a certain group or certain entities over the other. In the space of the idea, so I was lucky enough right now to have stepped in to listen to the talk by Jade, which was fantastic. This applies to that. So the idea, when we're thinking about bias in machine learning, on the idea stage, we're thinking, who is coming up with the idea? Who is this problem supposed to work for? And how are we going to then be able to evaluate it? And how do we test for its feasibility? What is the world that we're thinking that this idea is really going to work in? The second thing is the data. Where do we source the data? Who is counted in the data set? And I think this is actually one of the areas where bias in machine learning has been talked about, because it's about how are different entities represented inside the data set. Then it's about the model. The model that we choose, the reason there is so many different models is because the model is consequential to the results that one gets at the end. Even more important is how we fine tune, how we refine the model once we get to the end. Are we going to compress this model? Are we going to, what are other things? Are we going to introduce some privacy features after we build this model? All of these things. And then more especially about the model is, how are we going to evaluate its goodness of fit? How are we going to decide that now this model works really well to solve the problems that we need? Because a lot of the instances where we have come into problems of machine learning algorithms doing what we say we don't want it to do is because a lot of these models were not necessarily evaluated in those specific worlds by those specific people who would be interested to see in this sort of behavior also included in how the model works. But beyond all of this, when we start to thinking about the launch and the post-launch, we have to think about where the model is going to work, who is going to be impacted, how the power is shared inside that community. Because whatever the outcome, it does not affect all people the same way, just because of different structure and cultural things that are in the community. Now, these are some of the things that machine learning researchers and actually a lot more people, social scientists, lawyers, are coming into this field and thinking about bias in machine learning, because machine learning is definitely a technology that has spread out and is affecting different parts of our life. So we're thinking about how it manifests for law, how it manifests in ethics, how it manifests in governance and history, in all of these entities that it is now coming into. So we have gone beyond making sure that accuracy is the same between group A and group B, and now we are looking at how does this thing actually manifest in the real world. So where did this whole thing start? So there are so many articles about when machine learning algorithms have failed. So many examples. Some of the work, of course, was done by researchers, by Black researchers, because they found out that a lot of these systems were not necessarily working for them. So Joy, Timnit, these are just pioneering women who just went into this field and opened the eyes of so many people. But there were other things also, like when machine learning algorithms start saying that this person is to be jailed longer than this person deserves to have this treatment, this health treatment, and not this person. All of these really consequential things started to happen. So these decisions were being made by these machine learning algorithms, and they were really consequential, and they were affecting people's lives. And because of that, this is when the field and also all the other people who are concerned with issues of justice started to come in to question what is going on here. There was disparity in hiring. There's so many examples to draw out from here. But as you'll see even later on, we will get into like very like areas that we did not necessarily see at the time. So for example, Jay talked about decolonization of AI. So this, we've seen work being done by our fellow people in the Indaba. So Shakir led this paper about how to think about AI as a decolonial tool. Like, how do we make it so that it works for us? So we're not always thinking about AI as something that will launch and then we have to fix it to make sure that it works for our communities. But how do we phrase the whole thing so that from the onset, it is meant from our communities? So interestingly, for us, when I was working at the CSIR in around 2015 or so, around the same time, no, between 2015 and 2016, I can't really remember the date, but it was around the same time we're starting to also be around the same time the Indaba was going to start. We were thinking about this whole thing, and South Africa was going through the whole thing of like decolonized education. And we were thinking about what is it inside machine learning that we are not seeing. And so we actually started a project which did not get funded at the time, because this was not seen as something that was important to think about, like think about the error distribution inside machine learning algorithms. Of course, I think for a country with such different power disparity as South Africa, this was apparent for us, understanding how machine learning algorithms work. And so this is why it's so important for the people who are sitting here who work with machine learning algorithms to actually go through this and think through that. So like I've given a couple of examples, and that we have seen this sort of bias manifest itself in legal spaces. So it's going to be about sentencing. It's going to be about who do you grant bail to. It's going to be just a whole area, multiple areas where we're going to be seeing this bias manifest itself in the legal space. Medicine is another one, about who gets treatment. But then, of course, also for Black people, there's been this systemic failure of dermatological tools in AI, of working on black skin and being able to diagnose the diseases appropriately. And I think actually last year there was a great article. I can't remember the researcher himself, but I think he was a Black researcher, African researcher, who was in Canada, and he built this whole tool to actually address this, the specific thing of being able to diagnose diseases on Black skin. The hiring thing, if you have a Black sounding name, there is evidence that algorithms might discriminate against you. If you're a woman, these algorithms might discriminate against you. So in like both ways, in like picking up your name as good enough, or picking out your CV out of the batch and saying this is a great candidate, but then also in the kind of advertisements and job advertisements that different people get to see. So we were having this issue of different people seeing high-paying jobs or low-paying jobs, etc. So many people are in this field right now, like I have said. But why is this still here, and why is this so difficult? Because I promise you, this is a very difficult area to do. This is a very, very difficult place to find concrete answers. One of the things is because machine learning did not necessarily start bias in society. This is a problem that the researchers and the companies and everybody who is in this field inherited. That is one of the things. But of course, machine learning has been very instrumental at amplifying this problem. We may not have started it, but we certainly do amplify it. And of course, the sad part is that this technology was started to actually deal with trying to reduce this bias, but it seems it didn't exactly go that way. So why is it so difficult to solve? Technologically, it is actually difficult to solve. This is why there's a whole field of interpretability, and because we want to understand what is actually happening in the models, we need to be able to audit when the data goes in, what are the modifications that then lead to one output over the other. The second one is what I talked about, is the fact that this is a social problem. Once these algorithms go out, this is an inherited problem. The problem of data is a historical problem, because we have decided to document certain places and not document others. We have decided to document some places in a certain way and given certain ideas behind certain specific places or people or cultures. And so the machine is just inheriting that. And so now it is almost like we have to fight our own history and our own basis of cultures, in order to make sure that we try to serve people as fairly as possible. And then, like I said, there's also this disparity outside, which is that we harm different people. Different people have different impact. So for example, if you are a very wealthy person and the hiring algorithm does not choose you, it is a different story from somebody whose entire family put in their savings and fees to see this person through college. This person does great, and then this person is not picked by this hiring algorithm. Both of them are unfair, but the impact is different. So historically and just traditionally, we've had like two types of the way we measure fairness. So we measure fairness based, we can have group or individual. And I think I've already alluded to this when I say groups of people or individuals. So group fairness is about how do we fare when we are looking at a certain demographic versus the other. And then the individual is looking at two people. How do I treat one over the other? Group fairness is about the average. The individual is about the average, so like average over the groups. You're comparing the groups. You're not looking at the individual people or the individual entities. Individual fairness is thinking, if you've got two people who have the same profile, are you treating those two people the same? So these are the basic ideas behind. But like I said, this whole thing has exploded because machine learning fairness is not just about the algorithm that is running in your laptop. It is something that has come alive. And so now we're thinking about diversity, we're thinking about inclusion, we're thinking about ethics, governance, justice. And then, of course, as past colonial people, we're thinking about how to make sure that we are truly looking at problems through our lens and not through a colonial lens. So the types of harms, once again, I am sharing with you the fundamental, like machine learning. This is where we started type of thing. So we've had two types of harms that we talk about when talking about bias. We're talking about allocative harm and representational harm. So allocative harm, this is about like the hiring example. When it is about you've got something you have to allocate through a population. And then even though entities of that population look the same, you are biased one over the other. So if you're going to be allocating housing, if you're going to be allocating medicine, all of these kinds of things, if you've got a bias there, that's what we call allocative harm. And then representational harm is when you do not recognize certain habits or certain identities inside people, but you recognize them in other people, but these are shared. These are the same entity. So for example, Joyce's work, a lot of it was about this. It was about when a lot of these tools that were being used in technology companies wouldn't necessarily be able to differentiate in genders would not recognize Black women as Black women. But it goes beyond that. It goes to, for example, when Jade was talking, there'll be some languages or for example, some searches, some advertisement, which will be affiliated and associated with things that are negative, which are like just negative connotations or actually like negative imagery. So like I said, there's this disparity about who gets affected in this space. So more importantly, how does this happen? As I said, a lot of the discussions are about the data. And yes, so much of it is because of the data, but it is also because of the data, because so much is encoded in the data. The history is encoded in the data. The culture is the person, the people who were sitting on the table deciding on what is important is encoded in the data. But it goes beyond the data. It is about the model. So for example, we were looking at what happens when you compress model. This is work I did with Sarah Hooker. We did last year. And this is just like a sample result that we get. So when you compress model, this I found very important because for us here in Africa, we work with a lot of compressed models. So when you compress model, whatever model it is, so when you compress models, we verify this for language models and for vision models. When you compress models, you do not lose accuracy, or you do not lose correctness in a fairly distributed manner. There will be subgroups that lose accuracy way more than way more than other subgroups. So you will make more mistakes. So if we're thinking about the allocation, you will miss a lot more people in certain subgroup who should have gotten that job, who should have gotten that loan. You will miss them a lot more than you will lose in others. So in general, when we're thinking about compression, we usually think about the average loss. So I moved from a big model to a small model, and overall I had this kind of loss. But it's not about that. Once you slice that data up and you look at the subgroups, something very different emerges. So that's that. But there's a lot more. There's so many other works that show that the models, even whatever the data is, the more when you modify the model, you may not have a proportionate loss between all subgroups. Now, I've talked about the whole thing of ideas, but then also about evaluation. So the other project I wanted to share with you guys was about this work, which we did in defining diversity and inclusion metrics. And you can do this. So for us, we were interested because there are like a lot of work in machine learning, which is about ranking or about selection, where you have got to select a certain group out of a smaller group out of a larger group. And so we wanted to see, can we do this thing so that we're respecting things like racial diversity, gender diversity, age diversity, or any other. You see, this is nice because this is a place where you decide on the metric you want to optimize. Now, this is nice because it gives you a choice, but I think even more importantly is to realize that even when you're not making a choice, you are making a choice. Because if you do not specifically state something, you are still optimizing a certain metric. And in this case, we just actually went ahead and specified the metric that we wanted to do. And so we went through and we defined this. This was supposed to be for like selecting a subset out of this. And you can go, I'll share these with you, at least like all of these, you'll be able to follow once you look at the slide themselves. But what's the other thing that is very important about all this, like metric selection and evaluation, is that you can decide on the averaging or the aggregating function. That is actually really important. If you use one aggregating function over the other, you get different results. And we are always aggregating because we are always looking for groups. So choosing that aggregation function actually can change what you end up getting. So for example, here, perhaps one of the aggregating function I should have included is the function of Ubuntu. If there's a way to quantify and put it in about the relationship between the entities and how we can aggregate over people in such a way that we respect the Ubuntu principle, this could be one of them. And you could optimize with that. And actually, there was a paper that came out from some South African authors who actually did this, who used Ubuntu as an evaluation metric. Okay. But like I said, we have gone beyond evaluating the actual algorithms. We have gone into the space of justice and decolonization and into auditing the process of how we even get to the outcomes that we are at. And so I have put some of my favorite papers that actually came out in a year or in the past year. One of the ones I love, one of the ones I really love is the one that is written by Rediet Abebe. Is the one, this one on the left, Roles for Computing and Social Change. Why I think this paper is important for this audience is because this paper elucidates exactly what computing does to data, exactly the steps, exactly the decisions we make when we are using computational methods to solve a social problem. And I think that certain level of consciousness is very important, so that we do not think that there is magic happening, that in fact we are making conscious decisions which will have consequences for the people we are building for. But then, of course, there's also other work. So Ruha, she's an incredible author and also speaker who came to our Indaba 2 years ago, and just the power of that talk in situating what is important and all the work that we have to do, because we absolutely have to participate. We absolutely have to grab this. This is the reason I believe for the existence of the Indaba, of the IndabaX, of Masakani, is let us sit, solve the problems so that the solutions make sense to us. But another paper I love is this one, Data Science as a Political Action. This one tells us and reminds us that when we do data science, we are political. The English just ran away. This is the problem of speaking a second language. Actors, yes, we are political actors, and it is important to audit our actions all the time and make conscious decisions. But like I said, this is not just a social problem, this is also a technological problem. So for the models that already exist, it's so important to be able to use tools of interpretability, but then also the ones that don't work, we need to still go in. So interpreting, understanding, auditing is incredibly, incredibly important. Why is this exceptionally important for us here in Africa? Because we are a young population. These things that are being built, we are going to inherit them. These things, we are going to be the ones that live with them. And so it is absolutely important for us to think through all of these things and think, do we actually want the decisions be made in this sort of way? Do we want to build these kinds of tools? Do we want to focus our energies on the things we are focusing our energies on? And then finally, I absolutely love this one quote. It's by Julius Nyerere. And it is the predicament that I think many of us find ourselves, which is that we have been educated and lived in cultures and gained knowledge in cultures that are Western and have had slightly different or very different philosophies of how we serve and we group and we organize. And now the thing is, how do I adapt my work so that it fits within my current context, within my African context, without necessarily saying that everything from the West was bad? It was not necessarily. And so how do we get to that place? And then finally, I want to thank all these entities. These are some of the entities I have come across. And of course, these are some of the tools that do exist. The people through the Indaba and institutions such as AIMS and other like the governance, the global governance, but tools such as like the data search tools, Zindi as an entity that has constantly been promoting African data sets. And I'm sure all of the people who are entrepreneurs, all the entrepreneurs in machine learning, I do believe that these are the people who will answer the questions of bias for us in Africa, because they're truly auditing our own problems. And with that very speedy talk, that is the end. Thank you so much.
Thank you so much, Nyali, for that thought-provoking talk. I really enjoyed the talk, and there are some questions that we have, but I think since we'll be having a panel discussion next, I'll just shift those questions to the moderator for that panel so that we can have a discussion on that. So the next thing we'll be having is a panel discussion on AI ethics. the way forward to implementing fair and acceptable AI products. The moderator for this session is Salome Osei. Ms. Salome Osei holds a Bachelor of Science degree in mathematics from the Kwame Nkrumah University of Science and Technology, KNUST. She graduated from the African Institute for Mathematical Science, AIMS, Cameroon, with a Master of Science in Mathematics. Currently, she has been awarded the Google and Facebook scholarship to study a Master of Science in Machine Intelligence, of which she recently completed the program. She's currently a lecturer at Blue Crest University, and she aspires to be one of the few researchers in the area of machine learning applied to finance. And she also has an interest in translating African languages, especially Ghanaian languages. And as such, she's part of the Ghana NLP and Masakani. Her long-term goal is to extend this knowledge to others by lecturing in a university in Ghana. Over to you, Salome Osei, to moderate the session.
Hello, Hello, everyone, and welcome to the session on AI bias and ethics. Today, we will talk about the way forward to implementing fair and acceptable AI products. My name is Salome Osei. With me today, I have Nyalen Morosi, who already gave her talk. And then we also have Bellona Sona. So, Bellona is an ethics and gender issues manager at Afro Leadership and a research member at Z Inspection. Nyaleng, we already know, is a researcher in Google AI. So I will give them the opportunity to introduce themselves. So can we hear from you, Nyaleng?
Yeah, it's actually kind of nice to be looking at somebody now. I feel like I was like lecturing at my laptop. But anyway, thank you, everybody. I'm Nyaling. I'm sitting here at home in Lesotho. I'm from Lesotho. I'm back home. I'm usually in Accra, Ghana. I'm a research software engineer in their responsible AI part of it.
Okay, great. Thank you so much, Nyaleng. Bellona? Okay, so I think Bellona is getting set. So let me tell you something very fun. Actually, the program that I graduated from is where Bellona also was. So I haven't gotten to meet her personally, but I've heard of the works that she's done. And I also look up to her, judging from the fact that she came from my school as well. So if Bellona, you're ready, and you could introduce yourself for us.
Hi, Bellona. We see you. How are you?
Hi, Bellona. Can you hear from us? Okay, so it looks like Bellona is having a bit of a network challenge. So I guess I will start with you, Nyaling. My first question will be, why did you decide to work in this area? Why AI ethics and bias?
Yeah. It was an evolving thing, but by the time I got to Google, I think this was the area I wanted to explore more. It started from being working in South Africa at the CSIR. I know you guys also have the CSIR in Ghana. It's the same idea, these centers of research. So I was working at the CSIR in South Africa. And I was a data scientist, which of course these things always change, right? Like, yeah. So, but one of the things that happens is the CSIR is a national institute that works with government. That works with governments and works with other public entities. So governments, universities, startups, etc., NGOs. And one of the things that was clear for us was we were running into problems of proper data ownership. We were having problems of, we're also doing research in social media, issues of privacy, issues of just general knowledge of understanding what is happening with your data when you put it out there. I think this was most clear, of course, in social media, was just this understanding that sometimes we post, but machine learning tools are so good at sifting. So you might think that you're one of in a million and you're hidden, but they were so good at sifting that you could find who is this person behind any of this. And that felt uncomfortable, like a bit of a violation of privacy, because these people didn't always know that, you know, you could do this. And then I think working through governments and realizing some of the things that were necessary in order to make sure that the data, the rights of the citizens, the data, the processing, the this, and also of course like the tooling, that all of this sort of thing was taken care of. I think that became, like a lot of African government, they import technology, but some of the things that governments have to do is quite sensitive. And so what I wanted to, so the reason when I went to Google, really dived into the specific thing was we import these algorithms from companies such as Google. And I wanted to know what these algorithms actually look like. I wanted to work with people who build these algorithms and then think about them and audit them in this sort of way where we're thinking about the end users first, but specifically for us, the end user who may not know what this thing is and what this thing can do.
That is so great an inspiration to join an AI and ethics research community. But I want to ask, what happens if AI replaces humans in the workplace?
Like we don't go to work and robots do all the work for us?
Exactly.
That does not sound like the worst thing in the world. We could all get more naps, more hangout, more books to read, more time to take care of family. But I think one of the things that usually come up, I mean, this is the thing though. So if we are talking about robots going to an assembly line and putting together a car, I am not as against that. Of course, I would have a bit of a concern in how do I get an income? Because like I'm not working. Like doesn't mean the owner of the firm now just him and just fixing the robots, like that's the only payment that they do. So I think that can be a problem in terms of income and livelihoods. Of course, there's all these conversations that there would be like guaranteed incomes per citizen and la la la. I think Bill Gates has been like and like in these conversations about like the future of work, all these institutes, the Harvard Business Review will talk about it, all these people will talk about it. But this actually might be a really, really tricky thing, because now we're going to have an entity decide how much somebody should get. And given the rate at which we are having income inequality in the world overall, I am not sure we would necessarily be seeing a benevolent industry which makes sure that everybody is well taken care of. Also, it would just and once you don't have this sort of like a benevolent thing, or like you have this great disparity, you really run into some very, very serious problems of governance and stability in a country. So I think for robots to do the manual work is great, but we as citizens would have to have planned a whole system agreed upon and have guarantees that this is how we will then get access to income and all of the other things that we currently have access to. This is not something that we would like just leave it out there. But I only said like robots assembling like a car. Once we have these kinds of entities making decisions, like real decisions that have nuance in them, that have, like this finesse in them, like I was saying, should this child be accepted in this school? Or, should this kind of doctor be allowed to like operate, or like going through and giving us therapy, or any of these sorts of things that are so like these soft skills that human beings bring, that I don't think we are anywhere ready. I mean, we don't have good enough data. We don't have good enough evaluation metrics. We really, really don't. We absolutely do not have enough data, good data, and we don't have good enough evaluation metrics to be able to say that any system could do these kinds of things. So that should not be happening.
Well, I guess there are some people who still think that once these systems are in place, there won't be any need for humans. So, for example, if we have 30 people in a company right now, and then we have machines replacing half of them, where do the other 15 people go? I guess that's the challenge that we are all trying to avoid. So, what do you think could be solutions to the workload for humans? I mean, we're replacing it with machines, but what will the other humans be doing?
I mean, to be honest, there are people who have to go to work who actually would be great at something else that sometimes does not compensate well enough, right? I think, for example, we in Africa have a problem of being able to support our artists. And so suppose we had this choice and we had a way to guarantee that those 15 people would still be guaranteed a salary. I don't think people would like sit and read, even though I did start off by saying, oh, but that's because I'm dreaming of holidays right now. But people would then go and do other work that is not compensated so well. I think that would be that. And obviously this sort of thing has happened before where industries have changed, right? Like the way people work and how people work has changed, and how much labor is needed has changed, and all of these sorts of things have changed. We've had good things, we've got problematic things about them, like whenever that change happens. So I don't necessarily think that we would then have 15 people who are unemployed and wasting their time outside. I think systematically, like, communities are living organisms, and so they would just change, and like we would just have a different world. But like even today, we don't even actually need 15 people to be like out of work. Even today, we still need really good, solid social structures. Even today, like we don't even need that future. So that future should come, and we should have even better, or I don't know, social systems which takes care of communities and people.
Right. That seems like a very nice and thorough explanation to this. So, when we are at the workplaces, we always blame what faults comes to the human beings. Now, if we replace these humans with the machines and then there's a fault, who do we blame? So who's responsible for these mistakes?
We are responsible. We built the machines. I mean, we are always responsible. We did everything. We did absolutely everything. We put them there to solve that specific problem. We collected the data, we evaluated it, we deployed it, we did everything. Of course, we are responsible. Now, yeah, it's there will be like so many things that like lawyers and all the things about the margins and all the things will come through, of course. But at the end of the day, and I don't know how this is a fantastic question actually that I've been thinking about, because it's about who. Now I said the people are, but who specifically is responsible? Is it the company? Is it the researcher? Is it the software engineer? Is it the marketing people who went and sold your product that actually doesn't do what it said it does? Like, who exactly should be the one? Like, when an architect builds a bridge and the bridge collapses, that architect is responsible. And so we haven't defined this sort of thing. But I mean, at the end, people are responsible. And like I said, it's not a question of the machine or the person. It's a whole, it's an amalgamation of both. It's a twisted thing that we have and we built. We built it and we created it and we have to live with it and we have to constantly be updating it and improving it.
Okay. So how do we get rid of these mistakes? How do we get rid of these biases?
I think there was a point when I used to think that we could have great people on the table who care about fairness, who would make sure. Hi, Velona.
Hello.
Hi. Like we would have all these people who would make sure that, systems are ethical, they're inclusive, that they're fair, etc., etc. I actually think we are asking too much of any set of group of people, because what I understand as fair and just might not be what you understand as fair and just. We do have some shared understanding of what is fair and just, like don't go around just like chopping people's heads. Okay, that's really graphic, but I think we do all agree that is actually that's not great. But when we're thinking about how many engineering jobs should we allocate to like these people or this person, what is the salary? How do we fix like the salary disparity between men and women? Should we even fix it? What is, all of these sorts of things, there are things that are based on our cultures and our histories, etc., all of these things. So what I think we need, honestly, is to have a diversity of people building these solutions, like all the people in all the communities building the solutions for themselves. They understand themselves better. They understand what they need better. But then even more importantly, even if my community builds something that doesn't work well for me, I will look at the other community. I can look up to Namibia. I can look up to Rwanda. I can look up to DRC. And I can say, what about there? And if that works better for me, then maybe I'll go there. We already do this. When our countries don't exactly work for us, we move to another country, right? We already do this sort of thing. So I think even in this sort of thing, we can, once we have a diversity, once we have choice, human beings need choice. Once we have choice and we have all the voices or as many voices as possible represented, then I think we stand a very good chance. And now it looks like I'm alone on the panel. Oh, great.
No. So welcome, Bellona. Maybe you can use this time to talk about yourself. We've been discussing not quite a lot, but I know that we've been trying to talk about ethics and then bias and how we are going to get rid of these. So you can introduce yourself and put a voice in how to get rid of AI ethics and bias.
Hello everyone, I'm Belona Chuma, I'm Cameroonian and I'm ethics AI enthusiast. I'm actually working as a manager of gender issue at Afro Leadership, which is a non-profit organization who aims to include or introduce good use of technology in Cameroon in general. I'm in charge of gender issue because most of the time when we talk about the issues when we talk about challenges of technology, so most of the time we don't really care about women or minority on those technologies. This is what I'm doing daily. So I'm happy to be there today. Thank you for the invitation. I'm ready for the question.
Oh, thank you so much, Bellona. It's so nice to meet you. So, as I said, the question was, how do we get rid of AI ethics and bias?
Okay, to answer this question, I would say that first, we should know that to really to get right on of AI bias, we should first know the type of bias we encounter when we are designing.
Okay, so it looks we have a network challenge for Bellona still. So I guess I'm going to move on with you again, Nyalen. And I hope you're ready for the questions. Okay, so let me take this opportunity to read out the questions that you had when you were having your presentation. There were quite a number of questions for you, and I think this is a very good opportunity for you to actually address them. So the first question was, humans in our own cells are biased, which means that the discrimination against ethnic groups, discrimination against gender, color, etc. And this translates to the data sets that we collect. And as such, when these data sets are used to train ML models, these models just simply or amplify the existing bias we have in the world. And so the main question is, how do we resolve this issue with data bias?
So there's been lots of work that has been done on data bias. I think one of the greatest tools is to audit. Um, there are two sides to this thing. It's audit the data and then make sure that you're also thinking about it in the space of the problem you wanted to solve. So then actually I think that's very important to think about, because the data, you can have a data set with scope. Like, you can decide that I want to be very good at detecting houses in Lesotho. Like, I could do that, and that would be very important for me. That would be a problem. But I would fail at detecting houses in Cameroon, maybe, let's say. I mean, I would certainly fail at detecting houses in Las Vegas. Lesotho doesn't look like anything like Las Vegas. So you can do that. So it's very important when you're thinking and auditing through your data to think also about the problem. It just doesn't mean that you always have to worry about everything in your data set. You just have to worry about them in respect to the problem you want to answer. And then, of course, after you have audited the problem, the data set, then you've got to audit the results that you're getting and then compare. How do you fix data set bias? I am assuming that, and I like that you've already phrased it, that the bias is within ourselves. So I'm hoping that we are not, I can't say how to fix people. But how do you fix the data set actually after you have already gotten it? There are certain things that you can do. So for example, a lot of people will use GANs to sort of like, like smooth out, because sometimes you just have like certain groups just being really underrepresented. And so you can like create other data by like sampling over, like specific data set. And then, so a lot of people will use GANs for that. There's a lot of people, there's also, I mean, there are so many technological tools. You can reweigh certain groups so that the model differently penalizes getting those groups wrong. So like, if you already know that you have this one group really underrepresented, or that you have this one specific terrible stereotype attached to them, then when the model predicts that stereotype, then you penalize it really harshly, and then like it will stay away from that. So technically, there's a lot of these sorts of things that you can do. Of course, there's always the option of go find more data. That is really hard, and sometimes it is not. And interestingly, sometimes it's actually not even legal to audit like that, because like sometimes you're not allowed to like go through and look at the data set and look at the things, like you don't look at gender, you don't look at race, you don't look at where people live, you don't look at their health status and all of these, because people still have the right to privacy. But yeah, there's a lot of statistical things you can do. So in order to augment your data, in order to modify your data, in order to standardize your data, scale it up and down, and then of course resampling and all of these sorts of things. So one of these tools like Mixup, which became like a very big thing, and this was a paper by two of our people, Jan and Mustafa. They wrote this. This was really to try and like smooth out, like data in images. There's many tools. So yeah, there's that. But obviously there is this bias, and sometimes you just have to know that bias is there in your data set. I know I'm taking really long to answer this question, but I just want to say, because I like to like show that these things are like not new. These sorts of biases have happened before in other spaces. So, for example, in law, so in the legal discipline, they deal with this sort of thing of understanding that even if all evidence points something, sometimes you have to apply like mitigating circumstances. And I think the one thing that is really important with the machine learning algorithms where we went wrong was to believe that what they were saying was completely true and that it shouldn't be challenged. And I think as long as you challenge it, there's only so much you can do, but there's also not too much wrong you can do, because you have to do something.
Right. So I think this one also goes to say that there was a paper that Jade spoke about, which is Quality at a Glance. I actually am proud to say that I co-authored this paper, and it's about an audit. It's about auditing. So actually, you can anybody who wants to know about what's auditing and what could be done to our data sets, what suggestions we made, what we talked about, could actually look at this paper. Okay, that was just by the way. So we'll go on to your second question, which was, which of these types of fairness is hard to measure, group or individual?
Statistically, it should be group, right? Because anytime you get to average, that's a good thing. That means you can make some errors on some people and then like you compensate on other people, and then overall the average looks good. And so if you are there and you are tweaking and all of that, then and I think generally in a lot of people in machine learning feel that group fairness is a little bit easier to achieve. The reason why individual fairness is so tricky is because it is really difficult to define similarity when you're talking about entities such as humans. So to say that this person is exactly like this person and therefore they should get exactly the same thing, that can be really difficult, or any of this. So that's the thing. So the equality, that metric to define what you mean by entities are equal, can be quite difficult. And if you can't do that, then you can't do individual fairness, because you don't know who's equal to who. There's a lot of work where people talk about different attributes of human beings and intersectional attributes, right? Because we are many things. We are many things. And so what happens when you're now like, you have somebody who's not like, who is like a Black woman who did philosophy, African music, and then like spend 5 years in an AI whatever, and then like how do you equate that to like that person and then somebody who went to university and got their PhD and and then but all of this sort of thing, like how do you even do that? Like there's so many different features of us. It's not just like person and person, or woman and woman, and man and man. There's so many features. So that's where individual fairness gets a little trickier.
Yeah, so I remember that when you were speaking, you talked about the fact that sometimes actually auditing the data could actually give you some privacy issues. So if you were to actually collect data, what would be some of the good ways to collect data so that you are not invading in people's privacy, and also you are trying to get each of the races in one group of data?
The best way to not just collect data, to do work in machine learning, this is actually something also that Jade alluded to. The fact that to really work on a successful project, you need more than computer scientists. So I will also say the best way to collect data from people, of course, it helps if you can get consent from these people. We should always try to do that. Machine learning is really tricky at this because we need so much data, and getting consent from all those people can be really tricky, just to be honest about this. But ideally, we would get consent. But then besides that, I think it's very important, if this is a social problem, you absolutely need different stakeholders on that table. You need some community members, you need some people who are social scientists, you need some people who are in governance. Might be good to get a lawyer or two, good to get, like all of these people who look at this sort of thing from a very different eye. If this is going to be like medical thing, you're going to need a couple of maybe doctors, maybe some pharmacists, maybe some, all of these like lab technicians. It's very, because it's very difficult for you as a computer scientist, or actually it's very difficult also for you as a pharmacist to fully see the scope, because machine learning and data science on the ground is a multidisciplinary subject. And so you just need to have those entities. And even like I said, like, don't just bring in the professional. You need to understand the people for whom you are building this on. Like, that customer consultation is very important. That will then also guide you on how full and complete your data set is.
I think I was going to get to the parts where the lawyers come in and all that. So how is this process? Does it stress the person building the models? And if it doesn't go through, I mean, you don't get the required privacy consents. What in this case is done?
Okay, so there's multiple levels, right, of like working in machine learning. If you're working machine learning on your laptop and you're just trying to learn a technique, find the data that's available and learn the technique, and do the project. And like, or if you just want to see how maybe the cool algorithm you built might manifest in a certain place, do it. Just do it. But this is, so the kinds of projects I'm talking about would be like, let's say, projects that we would deploy at CSIR, right? Or like projects that could be like deployed by big companies. Like, if Google was gonna do this, like, they consult with a whole bunch of people. Because this is going to be something that's going to be on the ground and it's going to be consequential. But I don't want to like have people who are learning the things, like learning machine learning, want to get their fingers started, like just want to get started. Like, no, you don't need to absolutely go out and start getting like consent from like all the neighbors and all of the things. Just try something on your laptop, and that's that. But then, of course, if you want to launch it, and you want it to impact your neighbors, it's just good business, right? Like, you always go and talk to the customers about what they need.
Well, I guess this is a very nice solution or answer to the question that I asked. It's helping the community, so why not? I don't think that people would actually have a problem with you taking data to actually do something about what's wrong with them, like, for example, health issues that you mentioned. So now we'll get to the third question that you had when you were doing your presentation. You mentioned model compression, and there was a question that says that, what does it mean to compress a model?
I thought about this as I was flying right through the slides, and I'm so sorry to everybody. I don't always fly through, but there was a lot to talk about. I mean, like, model compression, it's like literally like if you had like a sponge and it was big and filling your hand, and then you squeeze it and you make it smaller. But because that's what compression means. It's just to like compress it and like make it take less space, right? That's what compression is. You just want to make it take less space. In computation, what do you mean by take less space? You mean that you don't want to remember as many weights. Remember the weights of the model, what you get, that at the end, that weight metrics, that is what it learned. That is what you get after you train, right? And so when we compress, we remove some of those connections. So we just set them to zero. Like, if you can imagine, like, let's say it's a neural network, and you compress those connections to zero so that you don't have to remember them, because they do nothing to your data set, right? Because you're going to be multiplying by zero. So that's what it means. So it just means like you just forget about the existence of certain ways. And so then when you store the structure of the model, you only have to store only a few weights. And so then that makes it take less space. It makes it faster. It makes it like, so, you don't have as much latency if you have got to, go back and forth. It's actually really, really good. It's a very, very good thing. And I'm grateful that we have this technology. So please keep compressing, but after compressing, audit. Like, make sure that it's still doing what you want it to do and do the things that it was doing before you compress it. So that's what compression is. It just means that your model takes less space on your memory board because, and also it will need less computation because you just remember much fewer weights. Now, I just want to say also about this compression, you can actually compress a model, like remove like 90% of the weights, like 90%, even 99% of the weights, and it will still work pretty well. This is what's amazing about compression. So you only remember 1% of the weights, and in some of these places, you'll still get up to like over 90% precision, up over 90% accuracy. So it's a great tool.
Well, since we are talking about compression, it actually says that it's going to actually do something to the model as people who are not really in the field think. But then what do we do about these unintended things that can come up? What can we do about it?
So that's good. One of the easiest things. So you imagine, right? So like I'm saying that you remove these weights, right? So one of the really popular compression method is to prune. And it's literally like when you remove some leaves on the tree and you don't need them anymore, you're pruning that tree. So it's the same idea, like you prune the model. So chop, 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 chop. And now you get a smaller model that has only a few branches. So one of the things you can do, which we always do all the time, is to fine tune it, right? So when a model fails at a certain place, we just overexpose it to those specific examples, right? So you can fine tune it, you can reweigh, but then of course, just knowing that, you're doing a bit of a trade-off, right? Because once you make it lean on one side, it might start to lose on the other side, but it's all a balance. But what's important is that you're aware, and now you can start to do some of these like fine-tuning things in order to be able to incorporate those examples that you're now bad at.
Well, it's been so amazing discussing this. I've actually gotten to know a lot that I thought I knew. I think I knew a lot. I thought that I knew a lot, but I don't think I know much now. From listening to you, I have added a lot of knowledge to what I already have. Now, I think that I would actually want to ask you the very last but one question, I guess, which will be, how do we use artificial intelligence humanely? How do we do that?
Oh, that is such a great question. Humanely. My God, how do we do so many things humanely? How do we, okay, so here's the thing. I think to start off is to remember that artificial intelligence is a tool. Computation itself is a tool. The whole thing is a tool. And we need to use it appropriately. It's just a tool, and you decide how you're going to use it. We have experience of how we have used tools before. So this is what I always start from. You have a problem. AI can help sometimes. But then also in the same way that you're not going to just like get a saw when you want to hammer something into a wall, you have to also, like, first of all, do you actually need machine learning or AI? Do you actually need that big algorithm, or can you just do basic statistics? Because they are all tools, and they are useful for some things and not so much for others. And I think, so that's the thing. AI is not, it can do amazing things. Our minds have gotten blown about so many things in this space. But we also have to then step back and then think about, but what was the problem I wanted to solve? Am I actually solving the problem I want to solve? So to like all the people who are listening today, grab this tool and get it to solve your problems. But be aware that you have a tool, and it can either break everything or it can help you build. And that's just that. It's great, but you gotta handle it with care.
Okay, so the tools are good, but we have to handle it with care. Thank you so much, Nyalen. It's been nice talking to you. It's been nice actually discussing with you. I mean, virtually. I'm actually a fan secretly. So I guess we'll talk about that maybe backstage. Um, okay, so what will be your final words to the community? What will be the final words to the people who are listening to you now? What do you want AI, people in AI to take from what you said today?
So one of the things I think is quite interesting is in some way how quickly one ages by AI years. And like how quickly one, especially when you're doing AI and you're also doing community work and for example, I'm like one of the people, I am like on like a Twitter break. And Twitter is like my AI world and I love it, but I am on a Twitter break. I was just like, okay, I need real world. I'm just gonna like step out. But what's really really important and why I would still come in and like work and be with the IndabaX, and I can't tell you how much, guys, I love the IndabaX. Like I love all Indaba. I might love IndabaX more than Indaba. Don't tell the other Indaba people. But anyway, because honestly, because what needs to happen, like what needs to happen in this place is just that we absolutely have to keep trying to solve our problems. We have to keep talking. We have to keep, so there, like the bias thing won't be such a big problem if we build this stuff. Like the thing that frustrates me the most is a technology goes out and it always has to be fixed for Africans, for Black people. Like always, like it's not just AI, it's like how medicine comes, right? Like medicine gets developed, then it doesn't work for us, then it has to be fixed for us. Like, you know, like cars and like how they measure road safety doesn't work for our roads, you know, like it always has, then you have to adjust it like for how like you measure like driver safety in Africa. Because but if we just build, let's just keep building. Like if we build, we won't need to do this stuff. And it's fun when we don't need to do this stuff, I think, you know, because I think sometimes this stuff can make it feel like, oh, AI is bad and we don't like AI and Black people don't like AI. No. It's a tool. We like it, but let's do it. Let's build. So that's all. Like I really believe the bias will go away when we create the stuff, because like it will be our everyday bias. It won't be imported bias, and that's fine. I mean, it's not fine, but you know, we know how to handle. Okay, we know how to handle lots of bias. Okay, I'm gonna stop. But anyway, I just want to encourage like people who want to build. Please build, and solve your own problems.
Okay, thank you so much, Nyalin. It's been amazing and wonderful having you today, and the discussion has impacted a lot of people. And I actually think that I had some questions, but then maybe we'll send it to you later for answers. Since you're on Twitter break, how do people get to see you? How do people get to reach out to you? Because I, for one, have been following you on Twitter, and now you say you're on Twitter break. So.
I know I've been on Twitter break like pretty much like since January. I just go in to reserve my name, but I'm gonna get back to Twitter because I feel good. I'm ready. These kinds of things are great. Yeah, it was just a break, so I'll be back on Twitter. But I'm happy for you guys to share my email and for people to get in touch with me if you want to take a call. Salome, yeah. If I can make time, and I always try to make time, I'll make the time. But I'll be back on Twitter. Yes.
Okay. So thank you so much, Nyaleng, for joining us for this panel. And I actually want to apologize on behalf of Luna Sona. Her internet didn't do her well today. So hopefully we are going to have her on another session come next year for the next IndabaX Ghana Summit. So today we spoke about AI ethics and we discussed the way forward to implementing fair AI. So now I would hand over to Deborah Doma Kanubala, and I would like to say that it was nice meeting all of you, and thank you so much. I'm out.
Bye-bye.
Wow, this was really, really, really an interesting session. And I would say I particularly enjoyed the talk and discussion on AI bias and ethics, because I think this is a very important area for all AI practitioners. And also it's an area I'm really interested in. So I guess this conversation could actually go on and on and on. However, thanks so much to Salome Ose and Nyale for this. We are really grateful. Well, all too soon, we are gradually coming to the end of the conference, and I wish this never came to an end too. Well, they say everything that's a beginning surely has an end. So at this point, I'll call on Lali, who would give us a closing remark and a bit of details about our Zindi hackathon. So, Delali, the stage is all yours now.
All right.
Hope you enjoyed the
Wonderful.
conference so far, though.
It has been so much fun, and I just wish we can continue, but I also know that people have other engagements that they are committed to. But absolutely, it was great, especially the sessions today exposes a lot of good mix of technical and non-technical talks that we all have learned a lot from. So I'm really happy for how everything went. So thank you.
Thank you too. So the stage is yours now.
All right. So once again, for everyone listening, I just want to thank all of you on behalf of the IndabaX Ghana and the Ghana Data Science Summit Planning Committee. We want to thank you for staying with us throughout the last 2 days. We want to actually thank all of our speakers. As you can see, we had speakers from different parts of the world, and some of them have to even wake up early morning at 2 a.m., 3 a.m. to join these events. So we want to thank all of our speakers as well. We want to thank all of our sponsors, from Deep Learning Indaba to Google, Maverick Research with 2 Analytics. We also want to thank our partners, Zindi, Academic City University, Tech TV, Superfleet Labs. We want to thank all of you for your immense contribution to this event. As we said earlier on, this is our second event. However, there's more coming. 2020 has caused us a lot of distractions, but also created a way for us to find ways to meet virtually. I want to say that we will continue to find ways to meet even virtually more often, so we can keep sharing more ideas. There are a few things that I would like to say in closing. In the past 2 days, we have had talks from data management through analytics, machine learning, AI, and we ended with AI ethics. If you think about all of this is basically the sequence of the things that we do in getting data, understanding the data, analyzing the data, building algorithms, and deploying the algorithms. And once we are deploying them, making sure that they are not biased, or making sure that they are fair, right? So the topics have been selected strategically to meet all of these needs. And so I hope that you have learned something throughout these 48 hours. As part of this conference, we've had a wonderful hackathon where people actually competed for a prize. We are yet to verify all of the results and check all the codes, and that these are Ghanaians staying in Ghana for the prize winners. I am very proud to announce that we have wonderful prizes for all the winners, and I'm just going to pull up and really tell all of you about all the prizes. So the first winner is going to have a cash amount of 2,000 cedis plus a mentorship from our partner, our sponsor, Google. Second prize will be 1,500 CDs plus mentorship from Maverick Research and Wave 2 Analytics. The third prize will be 1,000 CDs and mentorship from Superfluid Labs. We will be reaching out to all of these people who actually win these prizes and communicate the details and arrange the mentorship with them. In addition to the prizes for the first three, we will also give prizes for 4th and 7th positions. Sorry. These 4 to 7 positions will have free coupons to new books that are published by Daniel Gordy. We will work with all these guys to get you access to these free books. So as you can see, we have wonderful prizes for all the winners from position 1 all the way to position 7. And even people who will not have prizes, we will publish your name, the top 10 winners, so you can have what we call bragging rights. You never know. Through having this bragging right, an employer may just reach out to you because they've seen that you've been able to solve a real-life machine learning problem. The other thing that I would like to mention is that we are working to keep a live community of data scientists in Ghana and across the world. So be on the lookout. Like us on Facebook, follow us on LinkedIn and Twitter. Make sure that you subscribe to our YouTube channel. We will be doing watch parties of certain videos from time to time, and we are not going to wait and just have once a year type of conference. We are going to plan on meetup events. So I just like to inform all of you to be prepared for that. We will be sending out surveys for you to evaluate our sessions and our virtual conference, and so we can learn more from it and be able to improve upon our conference the next year. Once again, we just want to say thank you very much. And before I leave the stage, I would also like to say that for those of you who have submitted your resumes, that you are available for job, we are going to work with all of our partners. Some of them already requesting for us to send you all their resumes. Now, there are a lot of resumes that we've received, so these companies are going to work through all of them. And for the qualifying candidates, they will reach out to all of you and make sure that they can talk with you and arrange interviews and see if you are the right fit of their open positions. So, once again, on behalf of the planning committee, we just want to say thank you for participating, and please respond to our follow-up emails, and then we can get the conversations going. God bless you all. God bless Ghana. God bless Africa, and peace out.
Okay, thank you so much, Delali, for the closing remark. So it has really been fun, amazing, educative, and I learned so much. I got to meet new people, and we really enjoyed doing this. So from the team, the technical team, and myself, would want to say bye-bye to everyone. So come all over. So this has been the team bringing this. Bye. See you next year.
This is starting key producer.
I didn't know what was happening.